Biochemistry. Good morning, Arfad. In the biochemistry, the important thing here is, yeah, in most of the classes, what will happen, the moment I start with biochemistry, the students are like, sir, we are studying biochemistry for the very first time. So, my dear doctors, even if you people are also, any one of you is also attending like biochemistry for the first time, learning for the first time, don't panic here. I'm going to start biochemistry from the scratch and we are going to learn in a proper manner from the very, very beginning, sir. So don't think that, like I'm going to start any topic high five from somewhere in the middle or nothing like that. We are going to start every topic from the scratch and I'll teach you like very conceptually here. So we are going to learn in a proper manner, sir. Okay. So let's get started with biochemistry from the scratch. Follow my class properly. That is very much important, sir. Then only you'll be able to understand all the topics one by one because all the topics are like very, very properly arranged, sir. Okay. Thank you. Thank you, Nayat Kumar. Good morning, Abhilash. Abhilash. Sure, sir. So now, as I promised you, we're going to start from the scratch here, sir. So let's start from our school days basics here. First of all, like what is the meaning of oxidation, sir? Let us start from the school days basic days. What is the meaning of oxidation? Oxidation means addition of oxygen, removal of hydrogen, removal of electron, or increase in oxidation number. है ना? There are like 4 definitions, guys. That is very simple English. अगर आप oxygen add करोगे, if you're going to add the oxygen, it is oxidation. If you remove the hydrogen, it is oxidation. If you remove the electron, also it is oxidation. And finally, if you increase oxidation number, that is again oxidation. Exactly opposite of this one will be reduction. But we are not going to write down about the reduction here and confuse ourselves. No, we are not going to write down both the things and confuse ourselves. Okay, just write down oxidation and remember one thing. Opposite of this one will be the reduction, sir. Now, once you have understood all the 4 definitions, let me give you an example and we'll find out whether it is oxidation or reduction reaction, sir. For example, you all know iron very well. Iron will actually exist in 2 forms, Fe+2 and Fe+3. Fe+2 will be the ferrous form of the iron and Fe+3 will be the ferric form of the iron, sir. In biochemistry, there is a reaction where ferrous will actually get converted to ferric, sir. Ferrous will get converted to what's a ferric here. Right? So now tell me, is this reaction an oxidation reaction or a reduction reaction, sir? Now to understand whether it is oxidation or reduction, first what we'll do is we'll try to follow all the 4 definitions one by one, sir. Okay. The first definition which is given here is addition of oxygen. अगर आप यहाँ पर reaction देखोगे, in this reaction there is no oxygen at all. Okay. Second one is removal of hydrogen. If you look at this reaction here, there is no hydrogen at all there. Third one is removal of electron actually, but on electrons we are not going to fight right now whether electrons are added or electrons are removed. We are not going to learn that right now. Why? Because again we have to go back to our 11th and 12th class basics. All that the structure of atom, electron, proton, neutron and all, वो सब जरूरत नहीं है. And now welcome to my 4th definition here, increase in oxidation number. अब सर ये oxidation number क्या होता है? In this ferrous, whatever this number is written above here, that number itself is known as the oxidation number. So what is the oxidation number of ferrous? +2. Similarly, what is the oxidation number of ferric? That is nothing but +3, sir. Now, +2 to +3, is it increase or decrease? Increase in oxidation number. So yes, sir, this one is a oxidation reaction. Wow. Understanding? This is how you're going to decide whether it is oxidation or reduction, sir. Similarly, I'll give you like one more example. For example, there will be I-1. I-1 will be nothing but iodide ion. And iodide ion will be getting converted to I. What is I here, sir? I will be iodine. ठीक है ना? और फिर से दोबारा वैसे देखिए, sir. What is the oxidation number here? -1. And what is the oxidation number here? Yes. Wherever you don't have anything, sir. जहाँ कुछ नहीं होता है, वहाँ पर शून्य होता है. There is nothing, so it will be 0. Now, -1 to 0, it is actually increase in oxidation number. So yes, sir, it is an oxidation reaction. Yeah. Okay, now. So ferrous to ferric is an oxidation reaction. Iodide to iodine is an oxidation reaction. Whatever it is, I have given you like a couple of examples here. And by this, we are actually able to decide whether it is oxidation or reduction, sir. ठीक है ना? So wherever you are sitting and listening to me right now, let us revise the four definitions again here right now, sir. See, in my class, what you do is the moment you are writing there, try to learn it, sir. Learn along with me right now. What are the four definitions of oxidation? Addition of oxygen, removal of hydrogen, removal of electron, and increase in oxidation number. Now you might be thinking that why I am telling you about oxidation reaction in the morning, sir, here. In biochemistry, why I'm telling you about oxidation. So listen here, in our entire biochemistry, in our complete biochemistry, my dear friends, we are going to come across many oxidation reactions. And in almost all the oxidation reaction in biochemistry, we are going to follow this definition, sir. That is removal of hydrogen. We are going to follow the definition, removal of hydrogen. So whenever in the entire biochemistry I'm telling you oxidation, you are going to tell me removal of hydrogen. Okay? तो चलिए start करते हैं सर. For example, there is a substrate and a substrate is getting converted to what's a product. You know, and I am telling you that in biochemistry, this is an oxidation reaction. So my dear students, tell me, in biochemistry, what is the meaning of oxidation? Oxidation का मतलब क्या होता है? Removal of hydrogen. Now, as a simple medical student, I'm getting a doubt in my mind. Sir, you said oxidation reaction. We agreed. Sir, you said removal of hydrogen also. We agreed with this one. But now, what will happen to this hydrogen? Is hydrogen का क्या होगा? Listen to me very carefully now, my dear friends. This hydrogen will be accepted by hydrogen acceptors. And who are the hydrogen acceptors, sir? That will be NAD plus and FAD. Okay. That is why I'm telling you to listen very carefully here. Why? Because these two are not going to leave you till the end of the biochemistry, sir. Till end of the biochemistry, ये आपको छोड़ने वाले नहीं है. Now, NAD will accept the hydrogen to form NADH plus H plus. FAD will accept the hydrogen to form what, sir? FADH2. NAD will accept the hydrogen to form NADH plus H plus, or sometimes what will happen? FAD will accept the hydrogen to form FADH2. अब फिर से दूसरा वही सवाल, सर फिर इन दोनों का क्या होगा? What will happen to these two right now? Remember, these two are the one which are going to form ATP. And how they are going to form ATP? By passing through electron transport chain. NADH and FADH2 are going to form ATP by electron transport chain. And now you cannot ask me the question, sir, what will happen to ATP and all? No, you cannot ask me this question. Why? Because ATP is the source of energy that is used for our day-to-day work right now, sir. Like whatever work we are doing right now. So, my dear doctors, this picture should be like printed in your mind, sir. So now in biochemistry, whenever I'm telling you like oxidation करके ना, the moment I'm telling you oxidation reaction करके, so you have to repeat this entire story, sir. Entire story आपको ये repeat करना होगा. चलिए सर एक बार मिलकर हम लोग रिवाइज करते हैं. Yes, what is the meaning of oxidation in biochemistry? Removal of hydrogen. And that hydrogen will be accepted by NAD plus and FAD, sir. NAD plus will accept the hydrogen to form NADH. FAD will accept the hydrogen to form FADH2. Now, NADH and FADH2 are the one which are going to form what's the ATP by passing through electron transport chain. Again, I think my students are intelligent enough to understand here. Hello, Ji. My students are intelligent enough to understand here. Why am I telling you this entire story here, sir? ये सारी story मैं आपको क्यों बता रहा हूँ? Why? Because, yes, my dear friends, now we are going to learn what? Electron transport chain. And why are we learning electron transport chain? We got the idea very clearly. In electron transport chain, we are going to form ATP, to form ATP from NADH and FADH. That's all. So as I promised you people, I'm not going to start simply any topic simply like that, sir. For example, electron transport chain, मैं directly start नहीं कर रहा हूँ. I'm not starting directly, sir. I'm telling you the reason why we are studying this particular topic. So now my student knows very well. Why are we learning electron transport chain? To form ATP. यहाँ से हमको ATP मिलेगा, sir. तो इतना आसान है, sir. So just you follow my class properly here, biochemistry will become easy for you, sir. So now, my dear doctors, write down the heading there. The first topic that we are going to begin is electron transport chain. इसको हम बड़े प्यार से कहते हैं ETC. First, you write down the another name. In exams, sometimes they're giving you another name of this one, sir. It is also known as respiratory chain, sir. Electron transport chain, it is also known as respiratory chain. Now, first of all, definition. What is the definition of electron transport chain? What are you doing here, sir? From NADH plus H plus or FADH2. From NADH and FADH2, it is going to form ATP. From here, we are going to get what's a ATP. That is what is happening in electron transport chain. After definition, the next thing is location. ये कहाँ पर होगा? Remember, electron transport chain will take place in inner membrane of mitochondria. Many of the students will be knowing mitochondria, sir. Please underline inner membrane. It will be taking place on the inner membrane of mitochondria. After the location, then you write down there. It will consist of 5 protein complexes. Electron transport chain में ना 5 complexes होते हैं, and all the 5 complexes are made up of proteins, 5 protein complexes. And the names of the 5 protein complexes are very easy. They will be complex number 1, and then you'll be having complex number 2, and then there will be complex number 3, then complex number 4, and finally complex number 5, sir. So it is like introduction here. We are done with the definition, we are done with the location, as well as we are done with the 5 complexes, sir. 5 protein complexes are present here, sir. Okay, na? Now, now once you are done with this one, now once you are done with the introduction here, sir, now let us get started with the mechanism of electron transport chain, sir. और ये बहुत important है. Now let's see what is the mechanism of electron transport chain. Now we know very well electron transport chain will be taking place where? It is taking place on the inner membrane of mitochondria. तो चलिए हम लोग मिलकर draw करते हैं diagram. This one is the outer membrane of mitochondria, and this one here will be the inner membrane of mitochondria. So inner membrane will be having that folds which are known as cristae. आप सबको बताया sir. Now inside the inner membrane there will be matrix of the mitochondria. Outside the mitochondria there will be cytoplasm. Mitochondria is a cell organelle. तो कहाँ पर होगा? In the cytoplasm में होगा sir. Now, in between these two membranes, there is a space, and that space is known as intermembranous space. Outer membrane, inner membrane, between them there will be a space, and that space is known as intermembranous space. In between the two membranes, there is a space, intermembranous space. Now on the inner membrane, you'll be actually having 5 protein complexes. Complex number 1, complex number 2, complex number 3, complex number 4, and finally the complex number 5 will be like an open channel. तो ऑलरेडी मैंने आपको बताया था कि इलेक्ट्रॉन ट्रांसपोर्ट चेन कहां पर होता है सर? इनर मेम्ब्रेन में, एंड देयर लाइक टोटली हाउ मेनी कॉम्प्लेक्सेस विल बी देयर सर? 5 प्रोटीन कॉम्प्लेक्स विल बी देयर. ठीक है ना? टिल नाउ वी डिड नॉट स्टार्ट द मैकेनिज्म गाइस, डोंट वरी. अभी हमने मैकेनिज्म स्टार्ट नहीं किया है. आई एम जस्ट टेलिंग यू द planning here, sir. We are just making the diagram ready. Okay. So now you people tell me here if your diagram is ready right now, sir. अगर आपका diagram ready है तो मुझे बताइए, फिर मैं mechanism start करूँगा. Okay, Rahul, very nice. Are you ready? Thank you, Arafa. Now inside the mitochondrial matrix, आप मान लो, just imagine that somewhere oxidation reaction is taking place. Inside the mitochondrial matrix, कहीं पर oxidation reaction हो रहा है. Now, I told you just few minutes back, in biochemistry, the moment I tell you oxidation, what should come in your mind, sir? Oxidation का मतलब क्या होता है यहाँ पर? Removal of hydrogen, है ना? And that hydrogen will be picked up by NAD plus. NAD plus will pick up the hydrogen from here, and it is going to become NADH plus H plus. है ना? अब क्या होगा? Now what is going to happen? Now this hydrogen will be given to the complex number 1. And after giving the hydrogens to complex number 1, again it is going to become what, sir? NAD plus. Okay. The NAD plus will accept the hydrogen to become NADH plus H plus. And those hydrogens it will be giving to the complex number 1. And again it is going to become NAD plus. And after that, what is going to happen? It will transport those hydrogens into the intermembranous space. One concept is done neat and clearly, sir. Now, welcome to second concept, second point, sir. I told you in oxidation reaction, sometimes NAD will accept the hydrogen and sometimes FAD will accept the hydrogen. If FAD will accept the hydrogen, it is going to become FADH2. And this FADH2 will give the hydrogen to complex number 2. And after giving the hydrogen there, it is again going to become what, sir? FAD. Oh my God. Are you understanding here? So what is the take home point from here? The important point to remember from here is, yes, sir, NADH will give the hydrogens to which complex? Complex number 1. FADH2 will give the hydrogens to which complex? Complex number 2. That is important. And now listen with all your ears open, my dear friends. Complex number 2 will not transport the hydrogens on the other side. No. Complex number 2 will not transport the hydrogens on the other side. ये याद रखना जरूरी है. Already exam में पूछा गया था. Out of all the complexes, which complex will not transport the hydrogen, sir? Will not transport the hydrogen. That is complex number 2 will not transport the hydrogen, sir. Okay. Acha, if it is not transporting on the other side, then what will happen to those hydrogens? Whatever hydrogens are given from here to complex number 2, अगर वो transport नहीं होगा, तो then क्या होगा? फिर क्या होगा? What is going to happen? From complex number 2, they will go to 3. From complex number 3, they'll go to 4. And on the complex number 4, what is going to happen? Oxygen will combine with the hydrogens coming from above. So whatever these hydrogens are coming from here, these hydrogens are going to combine along with the oxygen. And together, they're going to form water. Okay. And now, on the complex number 4, are we adding the oxygen here? Yes, we're adding the oxygen here, sir. And I told you, that is the first point I told you today in biochemistry, that if you add oxygen, it is known as oxidation reaction. Okay. So which reaction is taking place on the complex number 4? It is oxidation reaction. What is the reaction taking place in the complex number 4? So oxidation reaction. Is it very clear? Now, some of the students I can see there, they are thinking in the morning, what is this? Azmu sir is teaching like very complicated things here, sir. Nothing complicated, my dear friends. I just taught you only 2 points till now, sir. मैंने आपको just 2 points पढ़ाया सर यहाँ तक. I just taught you only and only 2 points. Yes, Rahul, of course, it is very, very easy. मैंने कितने point पढ़ाए हैं आपको? Only 2 points, sir. Point number 1, let us revise here once more. NADH will give the hydrogens to complex number 1 and complex number 1 will transport on the other side. Khatam kahani. FADH2 will give the hydrogens to complex number 2, 2 to 3, 3 to 4, combine with oxygen to form water. That is the kahani number 2. Only 2 points are done, sir. And now welcome to the point number 3, and that is the climax of the story, sir. That is the end of the story now. Okay, now point number 3, dhyan se sunna, sir. Actually, what is happening is, over a period of time, NADH will keep on giving the hydrogen here and they are transported on the other side. Over a period of time, more number of H plus ions will accumulate here. More number of H plus ions are accumulating in the intermembranous space. In the intermembranous space. अगर यहाँ पर H plus ions accumulate होंगे, तो there will be higher concentration of H plus ions here in the intermembranous space when compared to that of the matrix. Okay. So higher concentration here and the lower concentration here because all of them are coming from the matrix into the intermembranous space. Now this H plus ions wants to move from higher concentration to lower concentration. I mean to say from intermembranous space to mitochondrial matrix. They want to come back from higher to lower. Fine. But the problem is H plus ions cannot cross this membrane. They cannot cross the inner membrane. So therefore, they'll keep on trying, keep on trying, keep on trying. And one fine day, they will come in contact with the complex number 5. And from the complex number 5, H plus ions will actually come back into the mitochondrial matrix. क्योंकि मैंने आपको बड़ा clearly बताया था कि complex number 5 is like an open channel. And from there, the H plus ions will actually come back to the mitochondrial matrix. Wow. Now, my dear doctors, if you people have learned physiology, in physiology there is one simple rule here, sir. एक छोटा सा rule है. अगर मान लो कि there is a membrane here, there is a membrane here, and if H plus ions are going to move across the membrane, if any substance is going to move across the membrane, energy will be generated. ये आपने पढ़ा होगा in the very first topic of physiology, that is diffusion. Okay, ना? Active diffusion, the passive diffusion होता है ना? Yes. In diffusion, this rule will come here, sir. Now, why I'm trying to recall this rule for you people right now? Why? Because, yes, you can very clearly see here, we are having a membrane. And yes, H plus ions are going to move across the membrane. So because of this reason, what is going to happen? Energy will be generated here. यहाँ पर energy generate होती है. My dear doctors, यहाँ पर ना थोड़ा सा आपको imagination लगाना पड़ेगा. Don't ask me to show the energy right now. So we cannot show the energy. Okay ना? So due to the movement of H plus ions, energy will be actually generated. और उस energy को हम क्या करेंगे sir? Trap करेंगे. We are going to trap that energy. So how we are going to trap the energy, sir? There will be adenosine diphosphate that will be combining along with the inorganic phosphate, sir. Adenosine diphosphate combines with inorganic phosphate. जब ये दोनों combine होते हैं, there is a bond formed. In that bond, we are actually going to trap the energy. And once you trap the energy in this bond here, it is going to become your ATP. The energy-rich molecule adenosine triphosphate, ATP form हो जाता है. Are you understanding me? So in this manner, make it like a nice story, sir. I repeat once more here. Due to the movement of H plus ions, जब H plus ions move होंगे यहाँ पर, energy produce होगा, और उस energy को हम क्या करेंगे? Trap करेंगे. And where are you going to trap the energy? In the bond between ADP and an organic phosphate to form one, sir, ATP. That's all. And because ATP is forming here, yes, it is formed with the help of an enzyme. And the name of the enzyme is very simple. Because ATP is forming here, it is ATP synthase. ADP synthase. And by the way, are we adding the phosphate group here? Yes, sir, we are adding the phosphate group here. So therefore, what is the reaction taking place on the complex number 5? It is phosphorylation. So on the complex number 5, what is the reaction? We are adding the phosphate group. So therefore, it is phosphorylation, sir. By this, entire mechanism is done hardly in 5 minutes, sir. So which topic are we learning right now, sir? Electron transport chain. In electron transport chain, we are going to form ATP from NADH or FADH2. Yes, you can very clearly see here from NADH and FADH2, we are going to form it, sir. ATP by electron transport chain. It's so easy topic, sir. So after completing the topic, my dear doctors, hardly like 3-4 points to remember here. Let us just revise those 3-4 points right now. NADH will give the hydrogens to which complex? Complex number 1. FADH2 will give the hydrogens to which complex? Complex number 2. Oxidation will be taking place on complex number 4. Phosphorylation will be taking place on complex number 5. What is the enzyme present on complex number 5? ATP synthase. And which complex will not transport any H plus ions? Complex number 2 will not transport the H plus ions. Complex number 2 complex number 2 transport nahi karega. Are you understanding me? Just for the sake of clarification, I just want to repeat this last whole part once more here, sir. Listen to me very carefully here. There is an inner membrane here, and H plus ions are going to move from higher concentration to lower concentration across the membrane. Due to the movement of this one, energy will be produced here. And that energy will be actually trapped. And where it is getting trapped, ADP, inorganic phosphate, there is a bond formed. In that bond, the energy will be getting trapped. Okay. And therefore, once the energy will be getting trapped here, it is going to become what? Energy-rich molecule, ATP form. And because ATP is forming here, all these things are not taking place automatically here, my dear friends. It is taking place with the help of an enzyme. The name of the enzyme is ATP synthase. Is it very clear? So once more revision. Now, after completing the revision here, right, my dear friends, Let us write down all the MCQs possible here. All the MCQs possible here. So, point number 1. On the complex number 4, oxidation is taking place. On the complex number 5, phosphorylation is taking place. And these two reactions will be taking place together. They are coupled together. That is the reason why this method of formation of ATP is known as oxidative phosphorylation. ये word आपने सुना होगा. So oxidation and phosphorylation are coupled together. That is why it is known as oxidative phosphorylation. Therefore, write down in electron transport chain, comma, in electron transport chain, ATP is synthesized by which method? The method will be oxidative phosphorylation. In electron transport chain, ATP is synthesized by oxidative phosphorylation. So, next one. Second point you write down here as synthesis of ATP, sir. Remember, synthesis of ATP will take place only and only by two methods, sir. One method will be oxidative phosphorylation. Synthesis of ATP will occur only by two methods, sir. One is oxidative phosphorylation, which I taught you just now in electron transport chain in detail here, sir. Another method of formation of ATP will be substrate level phosphorylation. Substrate level phosphorylation. That is SLP in short. Okay. और ये मैंने अभी आपको नहीं पढ़ाया है. Substrate level phosphorylation I did not teach you till now, sir. I will teach you wherever it comes. Right now, why I am making you write down this one? Just to make you understand that how many methods are there for synthesis of ATP, sir? Only and only two methods. One is oxidative phosphorylation, another one is substrate level phosphorylation. One more MCQ here, sir. H plus ions are not transported by which complex? Not transported by, yes, complex 2, sir. Complex 2 will not allow the H plus ions movement. ये भी आपके एग्जाम में पूछा गया था. This one also asked in your exam. Now, one more thing that you have to learn here is, apart from this one here, my dear friends, just now I taught you, like, how the ATP will be produced. So what is the method of formation of ATP? I taught you. Oxidative phosphorylation. मैंने पढ़ा दिया. Now, how many ATPs will be produced? So whenever you're going to begin with one molecule of NADH plus H plus, remember 2.5 ATPs will be produced. Okay. And whenever you're going to start with one molecule of FADH2, remember 1.5 ATP will be produced. Now within few minutes, we are actually going to learn about the pathways and all. So when you learn about the pathways, this thing will help you a lot in calculation of net gain of ATP. Okay. Now, so remember, from one molecule of NADH, 2.5 ATP will be produced. And from one molecule of FADH2, 1.5 ATP will be produced. Are you very clear with this one? Chaliye, sir, badhiya. Okay, now. So all these points are, if you learn, that will be very much important. Now, till here, if you learn, that will be required for your FMG exam, sir. FMG mein pucha gaya tha. If you are interested, tell me here about the one of the question asked in the PG exam, sir. Which is the final acceptor of H plus ions? Come on. अगर आपने ये पढ़ लिया, तो you're even ready for the PG exam, sir. Which is the final acceptor of H plus ions? Arafat is telling complex number 4. Anyone else? Options. Options will be given in the exam, not in the class. Nandini, complex number 5. Parikshit, complex number 5. ATP, complex number 5. I'll tell you the answer. Listen to me here right now, sir. This question was asked in your PG exam. NADH and FADH2, they're giving the hydrogens here, they're giving the hydrogens here. And the hydrogens are coming from the complex number 2 to 3, complex number 3 to 4. And I told you on the complex number 4, what is going to happen? Those H plus ions are accepted by oxygen to form water. So the final acceptor of H plus ions will be the oxygen, sir. Will be oxygen. So the final acceptor of H plus ion, your answer has to be oxygen. क्या बात. So all the MCQs are covered here, sir. By this, all the MCQs are done and done and done, sir. Okay. चलिए बढ़िया. Now, after completing all these MCQs here, sir, let me tell you one of the most important concept here from where the question can be expected in your July exam, sir. July exam में यहाँ से सवाल आ सकता है. So what you do is, first you drop your pen, sit back, relax, and just listen to the concept. You just listen to the concept first, sir. Then I'll make you write down the notes. Everything I'll make you write down. First you listen to the concept. Okay, now. Actually, there is a substance here. The name of that substance is 2,4 dinitrophenol, sir. There is a substance here known as 2,4 DNP, dinitrophenol. Now, what is the special thing about this one? This is going to combine with the H plus ions here, and then it is going to take the H plus ions into the mitochondrial matrix. Now, one good news, one bad news, sir. The good news is that it is going to carry the H plus ions from the higher concentration towards the lower concentration. Good, very nice. But the bad news is that it is not going through complex number 5. When it is not going through complex number 5, it is going directly through the complex number, it is going directly through the membranes. It is not going through to carry through the complex number 5. Sir. Okay. So, one good news, one bad news, sir. 2,4 DNP is going to carry H plus ions from higher concentration to lower concentration. But at the same time, it is not going to go through the complex number 5. It is going directly through the membrane. अब मैं आपसे ना सवाल पूछता जाऊंगा. You keep on answering me right now, sir. I'll ask you the question. You keep on answering me. Question number 1. Due to the movement of 2,4 DNP, is energy produced here, sir? क्या energy produce होता है? Yes or no? Bhavish is telling no. Remember, yes, energy will be produced. Energy produce होता है. मैंने आपको कहा था, like one of the rule from physiology, don't forget that whenever the substance is moving across the membrane, energy will be produced. तो energy यहाँ पर भी produce होती है. Okay, question number 1 done, sir. Yes, energy is produced. Question number 2. चलिए मैं आपको एक और मौका देता हूँ. I'll give you one more chance. Question number 2. Once that energy will be released here, is that energy released in the form of ATP? Is that energy released in the form of ATP? No. That energy is not released in the form of ATP, sir. Okay, na? Why? Because to form ATP, you require the enzyme ATP synthase, और वो enzyme यहाँ पर नहीं है. That ATP synthase enzyme is present along with the complex number 5. And this is not going through the complex number 5. तो यहाँ पर वो enzyme नहीं है. That enzyme is not present here. So ATP will not be formed. So what is happening to that energy which is released there? That energy will be actually released in the form of heat energy. Okay. So keep a very clear clarity between these two things here, sir. In the presence of 2,4 DNP, energy will be produced, but that energy will be liberated in the form of heat energy, not in the form of ATP, sir. क्योंकि ATP फॉर्म करने के लिए हमको वो एंजाइम चाहिए. ATP सिंथेसिस तो है नहीं है. That is not there. है ना? चलिए. Now the third point here, third and the last point here, sir, is phosphorylation reaction taking place here, sir? No. Phosphorylation nahi ho raha hai. It is not going through complex number 5. So now, just now I told you, oxidation and phosphorylation, I told you it will be like a coupled reaction. They'll occur together. Abhi मैंने आपको बताया था. They will occur together, oxidative phosphorylation, I told you. But now what is happening? This fellow is coming in the middle. 2,4 DNP is coming in the middle and it is uncoupling them, sir. Oxidation, phosphorylation, uncouple हो जा रहा है. इसको इसीलिए डॉक्टर्स ने इसका नाम सिंपल नेम रखा है, सर. It is known as uncoupler. It is known as uncoupler. Yes. Okay. So 2,4 DNP is like an uncoupler here, sir. And that is very, very much important for your MCI exam, sir. So please write down there as uncoupler. Now, what is the definition for uncoupler, sir? It uncouples oxidation and phosphorylation reaction. Therefore, ATP synthesis decreases and energy is liberated in the form of heat. That is important. ठीक है ना? So uncoupler का मतलब क्या होता है? It is going to uncouple the oxidation and phosphorylation reaction. Therefore, ATP synthesis will be reduced here. So ATP form नहीं होता है, but the energy will be liberated in the form of heat energy. So definition is okay, sir. We understood the definition, but now examples are really important here. Examples तो आपके एग्जाम में पूछा जाता है. One of the example I already told you 2,4 DNP, but in your exam they're giving you the full form here, sir. 2,4 dinitrophenol. And not only this one, even aspirin will also act as an uncoupler, and aspirin will be acting as an uncoupler only in high doses. अब यार ये बताओ, this aspirin and 2,4 DNP, are they produced in our body? Are they produced in our body, sir? No, they're not produced in our body. Aspirin is a drug that we are taking from outside. Now, do we have any naturally produced uncoupler? Yes. In our body also, the uncouplers are produced, and those uncouplers are known as physiological uncouplers. Those are known as physiological uncouplers. Now, what are the physiological uncouplers? Number one, already asked in your MCI exam, sir. Thermogenin will be a physiological uncoupler. And look at the beautiful name kept by the doctors. Thermo, heat, genin formation, heat formation. That substance is going to form the heat uncoupler. अच्छा, recently in one of the exams they have even asked कि thermogenin कहाँ होता है? Remember, thermogenin will be present in brown fat. Thermogenin will be located in the brown adipose tissues, brown fat. Number two, the second example here will be the thyroxine. Thyroxine will be your T4. Sir. Third example here will be the free fatty acids. Sir. And the fourth one here will be the bilirubin. Okay, no? So all these are the physiological uncouplers you have to remember for your exam. Sir. So thermogenin, thyroxine, free fatty acid, and bilirubin, all this will be acting like your uncoupler, physiological uncoupler. Examples important है. July exam में यहाँ से एक सवाल आ सकता है सर. From uncoupler they can ask you an example from here. ठीक है? Sure. Now let us wind up this topic here, sir, by summarizing everything here, sir. Let us summarize and wind up this topic here, sir. So write down exactly as I'm writing here. There will be complex number 1. And on the other side, there will be complex number 2. Leave some space in the middle, then you'll be having complex number 3. And then leave some space here, then there will be complex number 4. And finally, you'll be having the complex number 5. Now, first, let us write down the another name of this one here. Complex number 1, it is also known as NADH dehydrogenase. Complex number 2 will be known as the complex number 2 here will be known as succinate dehydrogenase. So here actually क्या होता है? Now what is happening here? Why I'm telling you this another names at the end of this topic here? Why? Because यहाँ पर कुछ concept नहीं है. There is no concept here. You need to just memorize the names, another name of that. So please write down and repeat the name in your mind. So complex number 1 will be NADH dehydrogenase. Complex number 2 will be succinate dehydrogenase. Complex number 3 will be cytochrome reductase. Complex number 4 will be cytochrome oxidase. And finally, the complex number 5 here, which will be FOF1 particle. Are you all done? Complex number 1 will be NADH dehydrogenase. Complex number 2 will be succinate dehydrogenase. Complex number 3 cytochrome reductase. Complex number 4 will be cytochrome oxidase. And finally, complex number 5 will be FOF1 particle. FOF1 particles. Done? After writing the another name of all these complexes here, sir, let us repeat the mechanism here. Right? Okay, now. Who is giving the hydrogens to complex number 1? NADH plus H plus will give the hydrogens to complex number 1. After giving the hydrogens, it is going to become NAD plus. Next is who is giving the hydrogens to complex number 2? FADH2. After giving the hydrogens, it is going to become FAD. Okay. Now listen, I'm telling you this for the first time. Complex number 1 and from the complex number 2, hydrogens will go to complex number 3, sir. And how they are going here with the help of a carrier, and that carrier will be known as coenzyme Q. And coenzyme Q here, it is also known as ubiquinone. So this is one mobile carrier here. And from the complex number 3 to complex number 4, again the hydrogens are going with the help of another carrier, that is cytochrome C, sir. तो ये दो कैरियर आपको याद रखने होंगे जो मैंने आपको पहले नहीं बताया. आई एम टेलिंग यू फॉर द फर्स्ट टाइम हियर, सर. So coenzyme Q, also known as ubiquinone, that is between 1, 2, and 3. And then cytochrome C, that is between 3 and 4, sir. Please remember these two carriers. बाकी का कहानी तो आपको अच्छे से पता है, you know very well. Whatever hydrogens are coming from above will be combining with oxygen to form what, sir? Water. And this reaction will be oxidation reaction. And complex number 5, so you cannot forget that entire story. I repeated 2, 3 times, sir. ADP will combine along with inorganic phosphate to form ATP. And because we're adding the phosphate group, this will be phosphorylation. Don't think that, Azam sir is selling like fast here, sir. So you know everything about this entire mechanism here, sir. Okay. So we are done with the names of the complexes. We are done with the transporters, mobile transporters, as well as we are done with the entire mechanism. And now welcome to the inhibitors of electron transport chain. And from there also you can expect one question from here, sir. Okay. Remember carbon monoxide poisoning. Carbon monoxide is going to inhibit complex number 4, sir. But in exam, they will not give you carbon monoxide is going to inhibit complex number 4, 5, 1, 2, 3. ऐसे ना option में numbers नहीं दिया जाएगा. In options, they will be giving you the names. And the name, you'll be getting confused between two names, sir. Cytochrome reductase and cytochrome oxidase. ये दोनों में आप confuse हो जाओगे. तो याद रखने का तरीका क्या होगा? What is the way to remember here, sir? Carbon monoxide, CO, inhibits CO, cytochrome oxidase. Carbon monoxide CO inhibits cytochrome oxidase CO. And recently asked you in your exam, cyanide poisoning. Cyanide is also going to inhibit complex number 4. As well as H2S, hydrogen sulfide is also going to inhibit complex number 4. So H2S, cyanide, carbon monoxide. Very, very important. Complex number 1 will be inhibited by, did you all study pharmacology, sir? In pharmacology, you'll be having barbiturates and benzodiazepines करके होता है. So in that barbiturates will be phenobarbital. Phenobarbital is going to inhibit complex number 1. Pharmacology में आपने पढ़ा होगा. This will be like sleeping pills, sir. But in India, it's like, madness, awareness नहीं है लोगों को. और ये लोग क्या करते हैं ना, वो फिल्में देखते हैं, हिंदी फिल्में and all, and then they'll be like, whenever there is some a little bit of tension in life, they'll open that bottle and then 10, 15 tablets they will take and suicide. So that is why I'm telling you, remember, that barbiturates are going to inhibit which complex? Complex number 1 will be inhibited by the phenobarbital. And not only the phenobarbital, even one more substance, that is rotenone. Even rotenone is going to inhibit the complex number 1. अब यार ये rotenone क्या होता है? Rotenone is insecticide which is used in the farming. तो farmers use करते हैं उसको ना farmings में. Insecticide होता है, insects को मारने के लिए use किया जाता है rotenone. Okay. And based on this only, there was a question given in your FMG exam last year only, sir, that there was a small boy and he has consumed a small boy has consumed a white colored odorless powder. These words were given. White colored odorless powder. Odor मतलब कोई smell नहीं था उसमें. वो consume कर दिया. And his father was a fish farmer. Okay ना? His father was fish farming. Okay, that hint was given. So in fish farming, a small boy goes near there and then he consumes the white colored odorless powder. Then it is going to inhibit which complex? So remember, they are speaking about which substance? Rotenone, and that is going to inhibit complex number 1. So complex number 2 will be inhibited by malonate. Complex number 3 will be inhibited by antimycin. And along with antimycin, BAL. And what is it, BAL, sir? That is British anti-levisite. Okay, British anti-levisite, sir. The antimycin and British anti-levisite, these two are going to inhibit complex number 3. And finally, complex number 5 will be inhibited by oligomycin, sir. हो गया. इसीलिए तो उसका नाम क्या रखा गया? That is why what is the name? The name will be FOF1 particle, sir. FOF1 particle. O stands for oligomycin, sir. Oligomycin. Understanding it? That's all. All the inhibitors are also done, sir. Okay, now. Now, my dear friends, remember, in this one diagram here, we are able to see here complex number 1, complex number 2, complex number 3, 4, and 5. Names are complete. Carriers are also done here. Entire mechanism is completed here, sir. Oxidative phosphorylation. As well as we are also done with the inhibitors. So, इसीलिए ना, this diagram is very, very much important for you people. Yes, my dear friends, this diagram is very much important for you to revise this one here, sir. Okay, now. Dr. Bindu is asking atractyloside. Okay, fine. Actually, if you remember these many, that is more than enough, sir. But still, if you want to remember, if you want to know about this one, so listen here, Dr. Bindu. Now, mitochondria है ना? तो mitochondria के अंदर ना, on the inner membrane, what is going to happen? Finally, ATP form हो रहा है, sir. By electron transport chain, ATP is forming in mitochondria. ये तो हम यार स्कूल डेज से जानते हैं कि mitochondria is a powerhouse of the cell. It is the one which is going to form the ATP. After formation, that ATP will be coming out. Okay. And after coming out, what is going to happen, sir? ATP will be utilized. और कैसे utilize होता है, sir? How it is utilized? Again, this ATP is going to break down to form ADP and organic phosphate. And this ADP will again go inside the mitochondria. और यहाँ पर it is going to combine with inorganic phosphate to form the ATP. ये चलता चला जाएगा. So what is happening is ATP is coming out and ADP is going in. I repeat again. ATP is actually coming out, whereas ADP is again वापस going inside the mitochondria. ये चलता चला जाएगा. And how is this happening? Of course, it will be happening with the help of a transporter here. तो यहाँ पर एक ट्रांसपोर्टर होगा. The transporter is transporting ATP outside and ADP inside, sir. ये चलता जाएगा. Now this transporter will be actually inhibited by the substance known as atractyloside. Atractyloside, sir. Is it okay, Dr. Bindu? So atractyloside is actually going to inhibit the ATP ADP transporter. ATP ADP transporter को inhibit करेगा, sir. Are you all done? Welcome, ma'am. Welcome. ठीक है ना? चलिए. And by this, what happened here, sir? By this, we are done with the entire electron transport chain topic is completed here, sir. This topic is done neat and clear manner. Are you all understanding biochemistry right now, sir? Hello, जी. So we started from the scratch. अगर आप देखोगे morning we started from the oxidation, reduction reaction and all. And from the scratch we started and we have learned the entire topic in neat and clear manner. All the MCQs are covered here, sir. So finally, to end this topic here, my dear doctors, remember, from electron transport chain topic, one question is definitely going to come in your July exam. July exam में एक सवाल पक्का आएगा. And that question will be actually coming from the uncouplers. They'll be asking you the examples of uncouplers, or that will be coming from inhibitors, sir. They can ask about the inhibitors in the exam, sir. Examples of uncoupler or inhibitors पूछा जाएगा. So please be ready. By this, in the morning. Yes, my dear friends, in the very first 1 hour, I have completed like one question for you. एक सवाल यहाँ से पक्का आएगा, sir. 1 mark for sure. And you people know very well what is the importance of 1 mark. Ask those people who got 149. 149, sir. 1 mark कितना important होता है? How the life changes because of that one. Again, next another 6 months, you have to learn the same syllabus, same subject, same faculties. And again, starting from anatomy, biochemistry, medicine, this, that, and all. And on to that, lot of mental pressure will be there. Ghar wale, and ghar wale to छोड़ो, relatives onto that one. So 1 mark is very much important, sir. तो थोड़ा सा patience रखिए, have some patience, and slowly try to learn the things along with me. जैसे मैं बता रहा हूँ, Don't be impatient. Some people were like, actually, when I was doing anatomy class, some people were asking me, yes, sir, biochemistry class pura completely फिर से attend करना जरूरी है क्या? And all those things. See, I will always advise it is better to actually attend the class once, even if you have attended before also, sir. Why? Because ये जो अगर आपने already पढ़ रखा है, I agree. Suppose you already if you studied. See, sir, there are like few subjects out of the 19 subjects, there are like few subjects which are very much volatile. For example, like biochemistry, then pharmacology, then PSM, as well as even the microbiology. These four subjects are very much volatile, sir. You keep on learning that one, you keep on forgetting because there is a lot to memorize here, sir. Memorize करना पड़ेगा, है ना? In pharmacology, all the names of drugs and their classifications. In microbiology, all those bugs, है ना? Bacteria, virus and all. तो बहुत memorize करना पड़ता है और वो भूल जाते हैं, sir. तो इसीलिए ना बेटर अगर आप क्लास अटेंड करोगे तो क्या होगा, इट विल लाइक अ रिवीजन फॉर यू. एंड माय डियर डॉक्टर्स, यस ऑफ कोर्स, इफ यू हैव लिसन द सब्जेक्ट वंस, अगर आपने एक बार सुन रखा है, तो अगर आप बैठकर रिवाइज करोगे, इफ यू रिवाइज yes, if you revise the topic by yourself, it will take a lot of time. It will take a lot of time. So if you have already done with the subject, don't do it from ABCD again. Don't do it from scratch again. Sit in the class with the mindset that you are just revising. You're just revising as you do after the class. So instead of that, you'll be saving a lot of time. Then after the class, you can do some other subjects, something like that. So that is the best way to approach. So don't think like, shortcut, but अच्छा लगता है कि attend नहीं करेंगे and all, but that is not going to help you. It'll, and like almost like 19 to 20 questions were asked last time. तो इसको पढ़ना बहुत जरूरी है सर. 90 to 20 questions matters a lot. Out of 150, suppose if you're getting some 20 questions from biochemistry, it matters a lot. Thank you, Shubham. Thank you. Sorry, done. Sorry, now I'll give you like 2 minutes of time right now, sir. One topic is done. One question will definitely come from here. All questions are from your notes only. Thank you, Shubham. Thank you, Bilash. Yeah. So I'll give you 2 minutes of time here, sir. Please turn the page back and revise this topic once, and then we'll start with another topic, sir. Fine. So 2-3 minutes of time. आराम से इसको revise कीजिए. Biochemistry आराम से हो जाएगा. चलिए, very good. You're done with the revision. चलिए. Now, after completing the electron transport chain, the next topic that we are going to begin, and a big topic that we are going to begin, sir, carbohydrate metabolism start करते हैं. Okay. And now in this topic, first I'll be giving you the overview here, sir. And जैसे मैंने आपको promise किया था, we are going to start every topic from the scratch. Let's begin from the very beginning here, sir. So for example, today we are going to consume the carbohydrate-rich diet. Carbohydrate-rich diet, sir. ठीक है ना? So nowadays, so like everyone is aware. So we know that carbohydrate-rich diet. So for example, you're consuming like rice, chapati, fruits, vegetables, and all. So when you're going to consume these carbohydrates, let's start from the consumption part. It will first of all go to your stomach and intestine, and their digestion will occur. So let us make a list of the carbohydrates that we are consuming on day-to-day basis. Number one, we are going to consume maltose, like whatever rice, chapati, fruits, and vegetables that you have, that will all have maltose in that. Whatever sweet substances you're going to consume, that will have sucrose in that. And then milk and milk products will have lactose. ठीक है, समझ रहे हो सर आप? तो मैं आपको ना बार बार कह रहा हूँ कि every topic I'm going to teach you from the scratch in a very well planned manner. We are not going to start something from hi-fi. I'm not going to start any pathways or something like that directly. कि biochemistry start किया and directly we are starting with glycolysis, Krebs cycle and all. No, we are starting from the scratch, from the time when we are eating the food, sir. Okay, na? From the time we are eating the food. So now after eating the food here, carbohydrates, maltose will get digested to form two molecules of glucose. Sucrose will get digested to form a molecule of glucose and a molecule of fructose. And lactose will get digested to form a molecule of glucose as well as a molecule of galactose. ठीक है ना? And maltose will be digested in the presence of an enzyme. The name of the enzyme will be maltase. Sucrose in the presence of sucrase. Lactose in the presence of lactase. And yes, sir, मुबारक हो, digestion complete हो चुका है. Digestion is done, sir. And now observe on my screen very carefully there. At the end of digestion of carbohydrates, what are you going to get here, sir? After the digestion of carbohydrates, we are going to get large amount of glucose along with little bit of fructose and galactose. So basically what I'm trying to teach you here is, many students are thinking that the end product of digestion of carbohydrates will get digested to form only glucose. Not only glucose, sir. Remember, we are going to get glucose as well as fructose as well as galactose, sir. So we are going to get glucose, fructose, and galactose, sir. Okay, na? So write down there, end product of digestion of carbohydrate is glucose, comma, fructose, comma, galactose. All three of them. Glucose, comma, fructose, and galactose, all the three of them are the end product of digestion. Okay. Next one, sir. Next one, after digestion, what is going to happen here? Absorption will occur, sir. Absorption होगा, ठीक है ना? तो absorption होगा यहाँ पर, and all this will be absorbed here. All the digested food material will be absorbed here. And after absorption, what is going to happen? The glucose and fructose as well as galactose, all the three of them will come to liver. And from the liver, what will happen? A required amount of glucose will be going into the blood cell. Our liver is actually a very intelligent organ, sir. Liver is an intelligent organ. So what it will do, whatever glucose is coming into the liver there, it will not allow all the glucose to go to the blood cell. All the glucose to go to the blood. It will be allowing only a required amount of glucose to go into the blood cell. Only the required amount of glucose will be going into the blood. Okay, fine here. Now my question here is that, मेरा सवाल यहाँ पर ये है कि sir, after eating the food, After eating the food will be getting digested. Fine. After digestion, why is the glucose going to liver? अब ये ग्लूकोज लिवर को क्यों जा रहा है एंड फिर वहां से ब्लड में क्यों जा रहा है? Why not directly absorbed into the blood? My question is why all this headache here, sir? Why not directly absorbed into the blood, sir? Okay. Malvika, the the doubt that you're asking me, that is not galactulose. That was the question asked last time in your FMG exam last year. That was actually lactulose. Lactulose is made up of what करके पूछा गया था. It is not galactulose. Is it okay, Malvika? Yeah. Now, what I was trying to tell you is that why it is going into the liver, why not into the blood directly? So, my dear doctors, remember, my dear friend. Yes, very good, very nice, Dr. Pradeep, for storage. Agar मान लो, like you people are learning very nicely, and because you people are learning very nicely and started the class along with me, I'm like really happy. Yes, my dear friends, you're learning very nicely and you have started the class along with me at 8 o'clock for the first time in life. So I'm like really happy, and out of this happiness, I'm giving you a party. Now, in my party, will you just eat like one or two chapatis or something like that? No. है ना जी? देखो confidence देख रहे हो. We are not going to just eat like one or two chapatis in the party, sir. We are going to eat like everything. Like starters, the main course, dessert, after party, पता नहीं क्या क्या खाते हैं सर. क्योंकि हम सबको पता है पार्टी में at the end of that you are not going to pay the bill. तो when you are going to eat a lot, जब आप ज्यादा खाओगे तो तब क्या होगा? It is going to get digested. Yes, large amount of glucose will be formed there. Large amount of glucose will be formed there. And then when large amount of glucose is formed, if that glucose is directly absorbed into the blood glucose level will go up like anything. Hyperglycemia. Am I visible now? Yes, sir. Now, what is going to happen? All the glucose is going to the liver. So now additional amount of the glucose, whatever additional amount of glucose will be there, that will be stored in the form of glycogen. And this pathway will be known as glycogenesis. The name is very simple, formation of glycogen. And sometimes what will happen, yes, glycogen even will break down to form glucose, and that is nothing but glycogenolysis. Glycogenolysis. So glycogenesis and then glycogenolysis, these two pathways will be taking place in the liver, and whatever it is, finally what is going to happen, required amount of glucose is coming into the blood. And via blood, what is going to happen? While the blood is circulating via blood, the glucose will enter into the cells. Glucose is entering into almost every cell in our body, and inside the cell, what will happen? The glucose will undergo metabolism, at the end of which we are going to get energy in the form of ATP. Are you all getting a point here, sir? So in this manner, I want you to learn. It's not like, starting with biochemistry and directly learning some reactions, some pathways and all those things. तो ऐसे पढ़ने का तरीका नहीं होता है, sir. This is the best way to learn. Are you understanding the point? Come on, my dear friends. Are you understanding me? तो चलिए हम लोग ना एक काम करते हैं. Let us summarize this again here once more here, sir. एक बार दोबारा ना हम इसको ना summarize करते हैं, sir. Let's start right now from the very beginning. So today, what are we going to consume, sir? We are going to consume the carbohydrate-rich diet today. All that, chapati, rice, vegetables, and fruits. After consuming this one, it is going to get digested to form glucose, fructose, and galactose. And it will be absorbed and it is going to first liver. In liver, additional amount of glucose will be stored in the form of glycogen. And whenever required, that is again going to break down to glucose. And then that glucose is going to blood and via blood going inside the cell. तो चलिए सर, अब हम लोग भी मिलकर लेट अस एंटर इनसाइड द सेल एंड लेट अस सी व्हाट इज हैपनिंग टू ग्लूकोज इनसाइड द सेल. सेल के अंदर ग्लूकोज का क्या होगा, तो चलिए हम देखते हैं सर. ओके ना? यस ऑफ कोर्स, शेक द ब्रेस. मॉर्निंग मॉर्निंग बिरयानी. अब चलिए सर, लेट अस एंटर इनसाइड द सेल एंड सी व्हाट इज हैपनिंग टू द ग्लूकोज इनसाइड द सेल. Now if this is the cell membrane, glucose is going to enter inside the cell, and it is going to enter inside the cell via a transporter, and that transporter will be GLUT, glucose transporter, sir. Recently in the last MC exam, they've asked one question regarding the glucose transporter also. Yes, we are going to study about all the types of them. But abhi ke liye nahi, sir. Right now we are going to learn what? We are learning the overview, sir. I'm telling you the entire planning. Now, once the glucose will enter inside the cytoplasm, it will undergo certain reactions to finally form pyruvate. And glucose to pyruvate, this pathway will be known as glycolysis. And remember, when pyruvate is formed here, pyruvate is formed in the presence of oxygen. So therefore, this one is known as the aerobic glycolysis. Okay. So in aerobic glycolysis, we're going to start with glucose and the end product will be pyruvate here, sir. We are going to start with the glucose and the end product will be what, sir? Pyruvate. Let me add few more points here. We are going to start with one molecule of glucose. At the end, we are going to get two molecules of pyruvate here, sir. Can anyone tell me like what is the formula of glucose? Glucose का formula क्या होता है? Formula of glucose will be C6H12O6, sir. Very good. तो C6 में मतलब कितने कार्बन होंगे ग्लूकोज में? 6 carbons will be there. And pyruvate will actually have like 3 carbons, sir. Please remember this number of carbons are very much important, sir. Glucose will have 6 carbon and finally at the end you're getting pyruvate and pyruvate will just have how many carbons, sir? 3 carbons. Achha, by the way, where is this process taking place? Where is the glycolysis taking place, sir? Glycolysis will be taking place in the cytosol. अब देखते हैं pyruvate का क्या होता है. Pyruvate will enter into one of the cell organelle here and this one will be the mitochondria. Now, once the pyruvate will enter inside the mitochondria, this pyruvate will now get converted to acetyl-CoA. Pyruvate has got 3 carbon. Acetyl-CoA will be actually having 2 carbons in that one. Now, this reaction, remember, it is not like a big pathway. It is just like one single reaction. So because it is like one single reaction, I will call it as like link reaction. इसको हम link reaction कहते हैं. And because it is like one single reaction, the name of the enzyme here will be PDH. This will be pyruvate dehydrogenase. Very much important. Already 2 or 3 times the question has been asked from here in your FMG exam. So pyruvate dehydrogenase. So pyruvate is getting converted to acetyl-CoA. Pyruvate is getting converted to acetyl-CoA by a single reaction, and that enzyme will be pyruvate dehydrogenase. अब acetyl-CoA का क्या होगा? Acetyl-CoA will now combine along with oxaloacetate, having how many carbons? 4 carbon. 4 carbon containing oxaloacetate, and together they are going to form citrate with 6 carbon here. So acetyl-CoA combines along with oxaloacetate to form citrates. Now this citrate will undergo certain reactions to form alpha ketoglutarate, 5 carbons, and that will get converted to succinyl-CoA with 4 carbons. And that succinyl-CoA will again convert back to oxaloacetate. I hope you are able to recall something here, sir. Yes, your favorite cycle here, and this cycle is referred to as your Krebs cycle. इसी को तो हम Krebs cycle कहते हैं. But again, the same thing, my dear doctors. Remember, Krebs cycle is not yet completed here. I told you very clearly, we are just going to learn what here right now. Overview हम लोग पढ़ रहे हैं, sir. I'm just telling you the important substrates over here. By the way, where is this link reaction and Krebs cycle taking place? The link reaction and the Krebs cycle are taking place in the mitochondrial matrix inside the mitochondria. Done. Now, my dear friends, why I'm telling you in this sequence here right now? मैं आपको ना इस sequence में क्यों बता रहा हूँ यहाँ पर? Why I'm telling you here like this? Why? Because when you start from glucose, number 1, I told you aerobic glycolysis. Number 2, I told you the link reaction. And number 3, I told you the Krebs cycle. So now you might be thinking like, why am I teaching in this order here? अब मैं आपको ना इस order में क्यों पढ़ा रहा हूँ? Why? Because listen here very carefully. Whenever you're going to start with that one molecule of glucose, number 1, aerobic glycolysis. Number 2, the link reaction. And number 3, the Krebs cycle. If these 3 things are done, it means that that glucose molecule has been completely metabolized. Completely metabolized. Understanding? Some students are thinking like very wrongly that हम जैसे यहाँ ग्लूकोज से स्टार्ट करते हैं ना, अगर ये ग्लाइकोलिसिस हो गया, if this glycolysis is done, they are thinking glucose is metabolized. No, sir, not at all. If only glycolysis is done, glucose is not metabolized here, sir. Okay, now remember, this one molecule of glucose will be metabolized if all the 3 things will occur, sir. Glycolysis, link reaction, and the Krebs cycle. If all the 3 things are done, it means that that glucose molecule is completely metabolized. समझ में आ रहा है बच्चों? Are you understanding me? So when can you say that the entire glucose molecule has been completely metabolized? Only if it is undergoing all the 3 things, sir. Number 1. And number 2, the most important thing which I love here, sir, I'll tell you like another important thing to understand from here is, let's go in retrograde manner, sir. Let us go in a retrograde manner here right now. Yes, sir? How? Can you please tell me where is this Krebs cycle taking place here, sir? Krebs cycle कहाँ हो रहा है? Mitochondrial matrix में हो रहा है. Perfect. Now this Krebs cycle is going to begin from here, acetyl-CoA. If I ask all my students right now, ये acetyl-CoA हमको कहाँ से मिल रहा है? We are getting the acetyl-CoA from pyruvate. From where are you getting this pyruvate? From glucose. From where is this glucose coming, sir? From outside the cell. And from outside the cell, glucose is coming from where here, sir? In the blood. In the blood, glucose is coming from where? Liver. और glucose liver में कहाँ से आ रहा है, sir? From the intestine after absorption. In intestines, from where are you getting this glucose? After digestion. Digestion of what? Food. And food is coming from where, sir? Of course, we are consuming it. This is the clarity that I want in your minds, in all of your minds about biochemistry right now, sir. But it's not like directly we are going to start something, some pathway, Krebs cycle. फिर हमको पता ही नहीं चल रहा है कि हम पढ़ क्या रहे हैं, sir. What are we learning? Where are we learning? Why are we learning? No. It should be like crystal clear in this manner. Okay. Now, after learning this so clearly here, please remember, I told you all these things will take place only and only in the presence of oxygen. अगर oxygen होगा तो. What if the oxygen is not available, sir? अगर oxygen नहीं होगा तो क्या होगा? In the lack of oxygen, I think you also have learned in pathology, cell injury. The most common cause of cell injury will be hypoxia. In hypoxic condition, what is going to happen? The glucose will undergo certain reactions to finally form what here, sir? Lactate. And this pathway is also known as what? Glycolysis. But this one will be the anaerobic glycolysis. Are you getting me? That is anaerobic glycolysis. What is forming at the end of this one here? Lactate will be forming here, sir. Are you getting me? Anaerobic glycolysis में क्या होता है? End product will be lactate. And in aerobic glycolysis, what is the end product, sir? That is a pyruvate. And now, my dear friends, on this side, I told you what will be the further metabolism of pyruvate. Pyruvate का आगे क्या होगा? मैंने आपको बताया. The link reaction and the Krebs cycle and all. But remember, on this side, there is no further metabolism of lactate. Lactate का आगे कुछ नहीं होगा. Lactate will just accumulate. Lactate will accumulate as lactic acid, sir. Are you understanding me? So, understanding, my dear friends? Are you done here? So whatever picture that you're able to see on the screen right now, whatever picture that we're able to see on the screen right now, my dear friends, here, yes, this entire thing is like a crystal clear diagram that I'm giving you. As an excellent doctor, please remember what is happening in the presence of oxygen here and what is happening in the absence of oxygen here, sir. Very, very clear. तो इससे हमको क्या समझ में आ रहा है? From here, what are we understanding here? Okay, so now we have to learn about aerobic glycolysis, anaerobic glycolysis, then link reaction, and the Krebs cycle. So these 4 topics we have to learn right now. Are you getting me? So my main intention is teaching you biochemistry very, very conceptually here, sir. Not like simply mugging up the reactions or not simply like, learning the topics which we don't know from where are we starting, where are we ending, तो हम लोग ऐसे पढ़ेंगे. ये होता है पढ़ने का तरीका. Are you understanding? Thank you, Dr. Tabrez. Thank you. So now we have to learn these 4 topics here, sir. Aerobic glycolysis, anaerobic glycolysis, link reaction, as well as the Krebs cycle. और ये हम पढ़ेंगे एक छोटे से ब्रेक के बाद में, सर. Why? Because to complete all these 4 topics, it is going to take exactly 2 hours of time. है ना? 2 घंटे का टाइम लगता है सर इसको कंप्लीट करने के लिए. और that I want to go do it in one go, one shot, without any break in the middle. We are going to learn them properly ताकि ना अच्छे से हमारे माइंड में कॉन्सेप्ट बनेगा. That concept will be made properly in our mind. So we are going to learn all these 4 topics after the break. Let's take a short break here, sir. या फिर अगर आपने ब्रेकफास्ट नहीं किया है तो have some breakfast, have some tea or coffee, and come back. We'll continue, sir. Even I will also have my breakfast right now. So let us take a break for like 20 minutes. And after 20 minutes, I'll join you together, sir, after the breakfast. Okay? चलिए सर, कार्बोहाइड्रेट्स कंज्यूम करके आइए, फिर हम देखते हैं चपाती का क्या होगा. What will happen to chapati after the break, sir? Okay, guys, चलो, take it. Welcome back, everyone. चलिए start करेंगे. Shall we begin right now? I hope you had your breakfast. तो अभी हम क्या करेंगे सर? I already gave you the overview before the break, like aerobic glycolysis, anaerobic glycolysis, link reaction, and then Krebs cycle. We are going to do all this 4 topics one by one right now. Okay, now. So let's get started with the first topic right now, sir. That is aerobic glycolysis. Now, the first thing to remember here is in glycolysis, what is another name of glycolysis, sir? Glycolysis is known as Embden-Meyerhof pathway. Glycolysis will be known as Embden-Meyerhof pathway. In short, it will be like EMP. So nowadays in the exam, they're using this name for the glycolysis, sir. Instead of giving glycolysis, they'll be giving Embden-Meyerhof pathway. The definition of the glycolysis, my student knows very well. We are going to convert the glucose to pyruvate, sir. In glycolysis, what is going to happen, sir? Glucose is getting converted to pyruvate. Location, my student knows very well. Yes, glycolysis will be taking place in cytosol. And after this, let's get started with reactions right now, sir. Now, my dear doctors, remember, there are totally like 10 reactions in glycolysis. That's nice, Tabriz. Yeah. So in glycolysis, there are like totally how many reactions are? Totally 10 reactions are there. And out of the 10 reaction, all the 10 reactions, I'm going to tell you like slowly, one by one, word by word, I'll tell you. I want you all to learn these 10 reactions right now in the class. Okay. So let's get started with the glycolysis right now. Glycolysis begins with glucose. And in the very first reaction, glucose will get converted to glucose 6 phosphate. Glucose will get converted to glucose 6 phosphate, sir. Okay? Now, how many carbons do we have in the glucose? Glucose has got totally like 6 carbons here, sir. 1, 2, 3, 4, 5, 6. 6 carbons here. And then what is happening here in the glucose 6 phosphate, my dear friends? Out of this 6 carbons, on the 6 carbon, there will be a phosphate group added here, sir. That is why the name will be what? Glucose 6 phosphate here, sir. Okay, so glucose is getting converted to glucose 6 phosphate. And then what is happening here in this one? In the very first reaction, glucose 6 phosphate का मतलब क्या होगा? On the 6th carbon, there is a phosphate group added here, sir. Okay. Now, the question here is that, sir, ये phosphate group कहाँ से मिलेगा? Remember, this phosphate group is added by ATP. ATP, the name itself is telling you adenosine triphosphate. It is going to add the phosphate group. After adding the phosphate group, it is going to become ADP, sir. ATP, it will add the phosphate group. It is going to become what? ADP. Then, now what will be the name of the enzyme, sir? The last and final thing is the name of the enzyme here. So in this reaction, remember, the name of the enzyme here will be the kinase. अब यार ये kinase ना आपके biochemistry में बहुत सारी जगह पर आएगा. But what is the meaning of kinase here? Remember, when are you going to use this name of the enzyme as kinase? Transfer of phosphate group from one molecule to another. Okay. So whenever there is a transfer of phosphate group from one molecule to another molecule, the name of the enzyme will be what here? Kinase. So whenever there is a transfer of phosphate group from one molecule to another molecule in biochemistry, you're going to use the name of the enzyme as kinase. Now, why I'm telling you about this rule right now? अब मैं आपको इसके बारे में क्यों बता रहा हूँ? Why? Because, my dear friends, welcome back to our reaction here. In this reaction, we can clearly see the phosphate group is getting transferred from ATP to glucose. The phosphate group is going from one molecule to another molecule. The phosphate group is going from one molecule to another molecule, sir. Done? That is the reason why the name of the enzyme here will be what, sir? The name of the enzyme here will be kinase. And the complete name of the enzyme here will be hexokinase, or else one more name here will be glucokinase. Hexokinase or glucokinase. Hexokinase or glucokinase. Perfectly done. तो यही तो मैंने आपको बताया था. This is what I told you, that all the reactions I will tell you, like, word by word, meaning by meaning. Why the name is glucose? Why it is named as glucose 6-phosphate? That phosphate group is coming from where? And then what is the name of the enzyme, sir? Kinase. So in this manner, I'll tell you everything here, sir. Right? Now moving on to the next one. Now moving on to the second reaction. Now in the second reaction, what is going to happen? Glucose 6-phosphate is getting converted to fructose 6-phosphate. Okay. Now again the same thing. Come on to the right side here, sir. What is the formula of glucose? Glucose formula will be C6H12O6. And similarly, what is the formula of fructose? C6H12O6. Now, what is happening here? Same formula. Formula is bilkul same here, but the name is different. Why it is happening like this here, sir? Formula अगर बिल्कुल same है तो नाम अलग अलग क्यों है यहाँ पर? Why the name is different? Why? Because formula is same, the structure will be different. And this concept is known as isomerization. Acha. And I don't want my student to remember like long definitions and all. Just remember two words here. What is the meaning of isomerization? Same formula, different structure. Same formula, different structure. So, same formula, different structure, sir. Understanding? तो इसको हम कहते हैं isomerization. And one of the best examples of isomerization will be the glucose and fructose. Glucose and fructose, sir. ठीक है ना? Glucose and fructose, guys. ठीक है? तो अब मैं आपको ये इसके बारे में क्यों बता रहा हूँ? Why I'm telling you, sir? Please welcome back to the reaction again. Now glucose 6-phosphate is getting converted to fructose 6-phosphate. So what is happening here? 6-phosphate and 6-phosphate is same. Glucose is getting converted to what, sir? Fructose. Glucose is getting converted to fructose. तो इसीलिए यहाँ पर क्या हो रहा है? Isomerization. So therefore, isomerase is the name of the enzyme. अब यार ये बताओ फ्रक्टोज में कितने कार्बन हैं? In fructose, you'll be again having 1, 2, 3, 4, 5, 6 carbon. On the 6 carbon, there will be the phosphate group here, sir. Perfect. And now welcome to the reaction number 3. Okay, now in the third reaction, what is going to happen here? Fructose 6-phosphate is now getting converted to fructose 1,6 bisphosphate. Fructose 1,6 bisphosphate, sir. So how many number of carbons do you have in fructose, sir? 1, 2, 3, 4, 5, 6. On the very first carbon, there will be a phosphate group, and the third carbon, 6 carbon, there will be a phosphate group, sir. Now in this reaction, already there is a phosphate group on the 6 carbon, but in this reaction, we are adding like one more phosphate group on first carbon, sir. In this reaction, we are adding like one more phosphate group on the first carbon. Okay. So that is why it is known as fructose 1,6 bisphosphate. फिर से वही सवाल, sir, where are you getting this phosphate group from? ATP. ATP will add the phosphate group here and become what's an ADP. Now again, because we are transferring the phosphate group from one molecule to another molecule, enzyme name will be kinase. And the complete name of the enzyme will be phosphofructokinase. And it is 1, sir, because we are going to add the phosphate group on the first carbon, PFK1. Phosphofructokinase 1, sir, PFK1. Sir. Perfectly done, sir. And by this, I hope you're understanding now. We are done with how many reactions till now, sir? We are done with 3 reactions. And every reaction I'm telling you crystal clearly, word by word. तो अब हम एक काम करते हैं, sir. Let's take a small pause here. And first, let us learn these 3 reactions here. Then only we are going to move ahead from here, sir. So which topic are we learning, my dear friends? We are learning glycolysis. What is another name of glycolysis? EMP, Embden-Meyerhof pathway. In glycolysis, the starting substance will be glucose. Glucose is getting converted to what, sir? Glucose 6-phosphate in the presence of hexokinase. And then glucose 6-phosphate is getting converted to fructose 6-phosphate, isomerization. And then one more phosphate group is added here. And therefore, it is going to become fructose 1,6 bisphosphate. Yaad ho gaya, sir? Are you learning along with me in the class itself? Hello, Ji. Are you learning all these reactions along with me now? Yes, sir. Now, why I'm asking you to learn the 3 reactions first of all? क्योंकि यहाँ से कहानी change होती है. Fructose 1,6 bisphosphate will actually split. DHAP, another one will be G3P. And it is going to split in the presence of an enzyme known as aldolase. Okay. Now, first, aram se, let us write down their full form here, sir. What is DHAP? Dihydroxy acetone phosphate. DHAP stands for dihydroxy acetone phosphate, sir. Done. And then G3P stands for glyceraldehyde 3-phosphate. First, aram se you learn this name, sir. So DHAP stands for dihydroxyacetone phosphate, and then G3P stands for glyceraldehyde 3-phosphate. Now listen very, very carefully here, sir. Ab suniye dhyan se. The moment it is going to split here, again what is going to happen? DHAP is immediately going to get converted to G3P. DHAP will immediately get converted to G3P because these two are isomers of each other, sir. ये दोनों एक दूसरे के isomers हैं. तो अब आप मुझे ये बताइए, how many molecules of G3P do we have right now? One molecule of G3P here and one more molecule of G3P over here. So we are having 2 molecules of G3P, sir. It means whatever reactions are going to take place on one side here, the same reactions will be taking place on the other side. I mean to say, everything will be like double, sir, after splitting. So after the splitting, everything will be like double, sir. Okay, na? So chaliye, sir. Keeping this concept in mind, let's get started right now with the remaining reactions. अब ये 5 मिनट में हो जाएगा. Glyceraldehyde 3-phosphate will now get converted to 1,3 bisphosphoglycerate. 1,3 bisphosphoglycerate. Now this reaction is an oxidation reaction. And the moment I'm telling you oxidation here, my dear doctors, I don't even have to teach you right now. Come on, tell me, what is the meaning of oxidation in biochemistry? Removal of hydrogen. And that hydrogen will be taken up by NAD+. NAD+ will pick up the hydrogen to form NADH plus H+. And whenever in biochemistry you're going to remove something, you're going to use the name as D means removal. And we are removing the hydrogen here. The name of the enzyme will be dehydrogenase. Dehydrogenase, removal of hydrogen. Very good, Rahul. And to write down the complete name of the enzyme, साथ में substrate का नाम लगा दो. What is the name of the substrate? Glyceraldehyde 3-phosphate. Wow. So what is the full name of the enzyme? Glyceraldehyde 3-phosphate dehydrogenase. 1,3 bisphosphoglycerate will now get converted to 3-phosphoglycerate. 1,3 bisphosphoglycerate is getting converted to 3-phosphoglycerate. अब यार इस रिएक्शन में क्या हो रहा है? What is happening in this reaction? To understand that, we have to actually go back a little here. Can you again tell me how many number of carbons do you have in fructose 1,6 bisphosphate? Fructose 1,6 bisphosphate has got how many carbons, sir? 6 carbon. And it is going to split here equally. That means there'll be 3 carbon here and there'll be 3 carbon here, sir. Fine. Now, in this, you're having how many carbons here, sir? 3 carbon. Now, read that name slowly and try to understand what is happening here. तो यहाँ पर कितने कार्बन होंगे सर? There are like 3 carbons here. Okay. 1,3 bisphospho. Okay. So there is a there is a phosphate group on first carbon and third carbon. 1,3 bisphosphoglycerate, sir. So now you only tell me in this reaction what is happening right now, sir. इस reaction में क्या हो रहा है? Now it is going to become 3-phosphoglycerate. So we are going to remove the phosphate group from first carbon. अच्छा, है ना? अब automatically हमारे दिमाग में सवाल ये आएगा, sir, after removing the phosphate group, what is happening to that? After removing the phosphate group, what is happening to the phosphate group, sir? So after removing the phosphate group, that will go to ADP, and ADP will accept the phosphate group to form ATP. So whatever phosphate group is removed here, it is first going to ADP, and from the ADP, it is going to accept the phosphate group to form ATP. Are we transferring the phosphate group? Yes, we are transferring from one molecule to another molecule. So basics मैंने आपको क्या बताए थे? Whenever you are transferring the phosphate group, the name of the enzyme should be kinase. Okay. So therefore, what is the complete name of the enzyme? Phosphoglycerokinase. Okay. Phosphoglycerokinase. Now, are you all able to see that there is ATP formed here, sir? Yes. So just before the break, I told you very, very clearly, ATP is synthesized by how many methods? ATP is synthesized by 2 methods, sir. One is oxidative phosphorylation, there is OP. Another one will be SLP, substrate level phosphorylation. And you can very clearly see here, it is the addition of phosphate group into ADP, that is phosphorylation at the level of substrate only, sir. So therefore, yes, my dear doctors, this is substrate level phosphorylation. Everything is given in the name itself. Substrate level phosphorylation, sir. Addition of phosphate group by ADP, substrate level phosphorylation. चलिए, अब क्या होगा? Now what is going to happen? 3-phosphoglycerate will get converted to 2-phosphoglycerate. यहां से तो यार और भी आसान है. It will be done in 2 minutes. 3-phosphoglycerate is getting converted to 2-phosphoglycerate. Tell me what is happening here. अभी यहाँ पर क्या हो रहा है? We are moving the phosphate group from third carbon onto the second carbon, sir. Okay. Now please add the basics. Basics are important. In biochemistry, we are going to use the name of the enzyme as mutase. और ये mutase आप कब use करोगे? तो whenever you're going to move phosphate group from one carbon to another on same molecule. Moving the phosphate group from one carbon to another carbon on same molecule, sir. ठीक. See, actually, what is the difference between kinase and mutase? Are you understanding? So kinase में भी हम क्या कर रहे हैं, sir? We are moving phosphate group only, but we are transferring from one molecule to another molecule. But in mutase, what are we doing? We are just moving the phosphate group on the same molecule only. तो यहाँ पर देखिए ध्यान से, we are moving the phosphate group from third carbon to second carbon on same molecule. Therefore, what is the name of the enzyme here? Mutase. 2-phosphoglycerate will now get converted to phosphoglycerate. इनोल पायरुवेट, और इसको हम बड़े प्यार से कहते हैं पेप, फॉस्फोइनोल पायरुवेट सर। एंड व्हाट इज द नेम ऑफ द एंजाइम हियर? फॉस्फोइनोल पायरुवेट, यहाँ पर एंजाइम का नाम होगा इनोलेस, एंड इनोलेस विल बी हेल्पिंग इन रिमूवल ऑफ वाटर मॉलिक्यूल फ्रॉम हियर सर। And the last and final thing here is phosphoenol pyruvate will finally get converted to what, sir? Pyruvate. Okay. And how it is getting converted to pyruvate here? Again, the same thing. Look at the name here, sir. Phosphoenol pyruvate is getting converted to pyruvate. So what is happening here? Phosphate group will be removed. And that phosphate group will be taken up by ADP to form what here, sir? ATP. Again, the same thing. Are we transferring the phosphate group? Yes. The enzyme का नाम क्या होगा? Kinase. What is the full name of the enzyme? Pyruvate kinase. And again, the same thing here. I can clearly see that there is ATP formed here, and this ATP is formed by SLP. So the ATP which is formed here is by SLP method, so substrate level phosphorylation. And that's all. तो अब आपको समझ में आ रहा होगा. Now you're able to understand here, my dear friends. It's all about what? Basics. The more clearly you know the basics, the same thing you have to keep on applying here. Okay. So whatever basics I'm giving you here, actually in the textbook it is written here and there in all random manner. So whatever is required at one place, I'm giving you at one place here. Sir. So finally, from glucose to pyruvate, glycolysis completed here. Sir. Glycolysis is like done and done and done, sir. Okay, na? Now I'll give you like 2 minutes of time here right now, sir. Please try to revise this glycolysis right now. Aram says slowly because it is going to come like again and again. So please revise this glycolysis right now here, sir. Any doubts? Let me know. Yes, Dr. Tabriz. Yes, that will be helping in removal of water molecule there. That is that. Okay. Any more doubts, anyone? हो गया सर, रिवीजन हो गया? चलिए बढ़िया सर. Now after learning this entire glycolysis here, sir, ये glycolysis टॉपिक यहाँ पर कंप्लीट हो जाने के बाद में now let us see certain important MCQs regarding this one here, sir. ठीक है ना? हेलो जी. Now can anyone tell me what is the net gain of ATP in glycolysis, sir? Before I teach you, can anyone tell me what is the net gain of ATP? Yes, very good. Very nice. Very good. Very nice, sir. चलिए सर, हम लोग ना अब ना मिलकर कैलकुलेट करते हैं. लेट अस कैलकुलेट टुगेदर, राइट? ओके ना? Now in this diagram, first of all, you're able to see that here there is a formation of NADH here. क्या फॉर्म हो रहा है सर? NADH फॉर्म हो रहा है. NADH is going to form how many ATPs? 2.5 ATPs. I told you before the break in electron transport chain. है ना? In electron transport chain, I told you very clearly from one molecule of NADH, we are going to get 2.5 ATPs. Okay. But I told you that after splitting, my dear friends, remember, everything will be like double. If NADH is forming here, the same NADH will be there on the other side also. So 2.5 here and 2.5 on the other side, sir. In total, how many ATPs will be there, sir? 5 ATPs. Similarly, from substrate level phosphorylation, we are getting 1 ATP here, and there'll be 1 more ATP on the other side. So 2 more ATPs, sir. And then 1 ATP from here, and then 1 more ATP on the other side. That will be 2 more ATPs. So 5 plus 2 plus 2, that will be totally how many ATPs? 9 ATPs, sir. So 9 ATPs are actually forming. Now, out of this 9 ATPs, we can clearly see in the first reaction, we are using 1 ATP here. And in the third reaction, we are using 1 ATP here. So from 9, if you're going to use like 2 ATPs there, the net gain will be how many, sir? The 7 ATPs. So my dear doctors, please write down there. Therefore, net gain of ATP in aerobic glycolysis is 7 ATPs. Net gain of ATPs in aerobic glycolysis will be how many, sir? 7 ATPs will be there, guys. Understood the calculation here? Now, after calculating the net gain of ATPs, the next thing will be the regulation of glycolysis. Where are you going to regulate glycolysis? Regulation of glycolysis will be done at rate limiting enzyme. And rate limiting enzyme, will be writing it as RLE. And the rate limiting enzyme of glycolysis will be PFK1, phosphofructokinase 1, sir. Now, what is the meaning of rate limiting enzyme, sir? It is given in the name itself. From the name itself, you can understand rate is nothing but the velocity limiting controlling enzyme, sir. So it is enzyme where we are going to regulate or control the glycolysis. अगर आपको glycolysis को stimulate करना होगा या inhibit करना होगा, you are able to do it at the rate limiting enzyme, sir. PFK1. Then glycolysis is reversible or irreversible. Remember, my dear friends, it is irreversible. So we need to learn what are the irreversible reactions of glycolysis. There will be totally 10 reactions in glycolysis. Out of the 10 reactions, 7 are reversible and 3 will be irreversible reactions, sir. Glycolysis is irreversible. There are totally like 10 reactions in glycolysis. Out of that, 7 are reversible, 3 will be irreversible reaction. Now, which 3 reactions will be irreversible reaction? The first one, HKGK, the rate limiting step, PFK1, and the last one, that is the pyruvate kinase. So the first step and the last step and the rate limiting step, sir. The first step and the last step and the rate limiting step, these three are the irreversible reactions of glycolysis. These are the irreversible reactions of glycolysis. Then this has been asked in your MC exam many a times. So then the next one, do you have any inhibitor of glycolysis? Yes, we do have an inhibitor of glycolysis. And that inhibitor will be the fluoride. And fluoride inhibits which enzyme, sir? It is going to inhibit enolase. Fluoride inhibits enolase here, sir. Fine. But in the exam, be careful there. They'll be writing there as NaF, sir. Sodium fluoride. Sodium fluoride करके दिया जाएगा आपको. So you have to be like really careful in the exam. Are they giving you fluoride directly or sodium fluoride? So in the sodium fluoride, what is going to happen? Forget about sodium there, sir. Fluoride. Fluoride inhibits which enzyme? Enolase, guys. And once you are done with the inhibitor here, the next one will be the last and final thing, sir. In the very first reaction, I told you glucose will get converted to glucose 6-phosphate. What is the name of the enzyme? Hexokinase or glucokinase. Now the problem is many of the students are thinking that hexokinase is another name of glucokinase and glucokinase is another name of hexokinase. My dear friends, it is not at all the another name. These two are separate enzymes, sir. Two different enzymes. So on one side, you write down there as hexokinase. On the other side, you write down there as glucokinase. I'll tell you the difference. Hexokinase will be present in almost all the tissues in our body, whereas glucokinase will be present in the liver cells. Hexokinase ना सारे tissues में होता है, लेकिन glucokinase कहाँ पर होता है? It will be on the liver cell. Now, in your exam, the question was insulin will act on which enzymes? Out of these two, insulin कहाँ पर काम करेगा? Remember, insulin will act only on the glucokinase. That too, it is going to induce glucokinase, but not on the hexokinase. Insulin induces which one? Glucokinase only, not on the hexokinase. It's very easy to remember. Why? Because you can clearly see here. Hexokinase कहाँ पर होता है? It is present in almost all the tissues in our body. अब यार ये बताओ, will insulin act on all the tissues in our body? No. Insulin सारे tissues पर काम नहीं करेगा. Okay. Yes, insulin definitely will be acting on the liver cells. So it will be acting only on glucokinase, not on the hexokinase. Done. And by this, all the points regarding glycolysis are done and done and done. So we are done with hexokinase, glucokinase. We are done with inhibitor, irreversible reactions, rate limiting enzyme, calculation of net gain of ATP, reactions, location, everything done, sir. Aerobic glycolysis हो गया. If you have any doubt, let me know here, sir. So in this entire overview, we are now done with aerobic glycolysis. In cytoplasm, Pradeep Kumar. Chaliye, sir, done. Are you done with this one here? Now, after completing the aerobic glycolysis, let us go towards the anaerobic glycolysis right now. But before moving towards the anaerobic glycolysis, sir, I'll ask you one question here. आप लोग silently सुन रहे हो? Can you please tell me in RBC which type of glycolysis will occur, sir? RBC में कौन सा वाला glycolysis होता है? Aerobic होता है कि anaerobic होता है? ठीक है. So what you do is on one side you write down there as aerobic glycolysis. On the other side you write down here as anaerobic glycolysis. Remember, aerobic glycolysis will occur in the presence of oxygen and mitochondria. Sir. ऑक्सीजन एंड माइटोकॉन्ड्रिया मतलब दोनों भी जरूरी है ऑक्सीजन भी चाहिए और माइटोकॉन्ड्रिया भी चाहिए both of them are required sir okay if suppose if the oxygen is absent or mitochondria is absent sir if any one is also absent it will lead to what anaerobic glycolysis so there's the difference between aerobic and anaerobic sir anaerobic means अगर मान लो कि ऑक्सीजन एब्सेंट होगा या माइटोकॉन्ड्रिया एब्सेंट होगा दोनों में भी क्या होगा anaerobic glycolysis होगा. Now, for example, I asked you just now which type of glycolysis will take place in RBC. So remember, in RBC, anaerobic glycolysis will occur, not aerobic. और अगर आपसे किसी ने reason पूछा why it is happening like that, it's because there'll be no mitochondria. Don't say that there'll be no oxygen there. In RBC, it will be anaerobic glycolysis, but यार oxygen तो होता ही होता है. RBC is the one which is going to carry the oxygen. तो उसके अंदर तो oxygen भरा पड़ा है. तो ऑक्सीजन इज ऑलरेडी देयर बट देयर विल बी नो माइटोकॉन्ड्रिया इट इसीलिए यहाँ पर कौन सा वाला ग्लाइकोलाइसिस होता है सर एनारोबिक ग्लाइकोलाइसिस होता है एंड नाउ आई होप यू आर अंडरस्टैंडिंग वी आर एक्चुअली डन विद द एरोबिक ग्लाइकोलाइसिस एरोबिक हो गया है एंड नाउ लेट अस लर्न अबाउट द एनारोबिक ग्लाइकोलाइसिस ओके and again the same thing let us start with the reactions one by one glucose will get converted to glucose 6 phosphate then fructose 6 phosphate then fructose 1,6 bisphosphate. This will be splitting into DHAP and G3P. G3P will get converted to 1,3 bisphosphoglycerate, then 3 phosphoglycerate, then 2 phosphoglycerate, then phosphoenol pyruvate, and then pyruvate. Let us do the same thing on the other side also. DHAP will now get converted to G3P, then 1,3 bisphosphoglycerate, and then 3 phosphoglycerate, and then 2 phosphoglycerate, phosphoenol pyruvate, and then finally pyruvate. So as I told you, we are going to start with one molecule of glucose. At the end, we are getting 2 molecules of pyruvate, hence proved. Now in this, let us even include the ATP also, sir. In the very first reaction, we are going to add one ATP here. In the third reaction, we are going to add one ATP here. Okay. Now in this reaction, oxidation is taking place. Oxidation में क्या होता है, sir? What is going to happen in oxidation? A remole of hydrogen, and that is taken up by NAD plus to form NADH plus H plus. Here there is a formation of ATP by substrate level phosphorylation, and here also there will be formation of ATP by substrate level phosphorylation. Exactly the same thing on the other side. Let us just do the copy paste. NAD plus will accept the hydrogen to form NADH plus H plus. Again, there is a formation of ATP here by SLP. Again, there is a formation of ATP here by SLP. Done. Okay. Now, if anyone did not understand how to calculate the number of ATPs, I think this is the best way to calculate here, sir. Look here. How many number of ATPs from NADH? 2.5. How many ATPs from NADH, sir? 2.5. 2.5, 2.5, totally how many? 5. 6, 7, 8, and 9, sir. Totally how many are produced here? 9. Out of this 9, 2 are used here, sir. 9 minus 2, totally 7. Net gain of ATP will be 7 ATPs. Perfectly done. Now some students might be thinking here, okay, why the hell I'm again teaching you the aerobic glycolysis here, sir? No, no. We are actually learning anaerobic glycolysis only. Now in anaerobic glycolysis, what is going to happen? Look here, so this pathway kitna aasan hai. It's so simple. Right from glucose up to pyruvate. Right from glucose to pyruvate. All the reactions are same. I told you all the reactions step by step, one by one, sir. Till pyruvate. Now, अगर मान लो कि ऑक्सीजन नहीं होगा या फिर अगर मान लो कि माइटोकॉन्ड्रिया नहीं होगा, if there is no oxygen or no mitochondria, then what is going to happen? Pyruvate will just get converted to lactate. खत्म sir. Anaerobic glycolysis हो गया. So only and only one reaction you have to learn here is that pyruvate will get converted to lactate. Sir. Such an easy thing. Yes. But here you have to be careful. In this, pyruvate is getting converted to lactate by addition of hydrogen, sir. I'm telling you, not by removal of hydrogen, by addition of hydrogen. Now, who is going to add the hydrogen? NADH. After adding, it is going to become NAD plus. Addition of hydrogen. Now, the next question in our mind will be, sir, from where are you getting this NADH, sir? ये NADH हमको कहाँ से मिल रहा है? So थोड़ा सा ऊपर देखिए. This NADH is coming from here, and this NAD plus will go from here, sir. Wow, beautiful planning here, sir. Beautiful planning and beautiful diagram here. Now, what is the name of the enzyme here? Pyruvate to lactate. The name of the enzyme will be LDH. The very famous one, lactate dehydrogenase. Lactate dehydrogenase. Similarly, let us go on the other side here. On the other side, let's do it again here. Pyruvate will be now getting converted to what here, sir? Lactate. By addition of hydrogen. Who is going to add the hydrogen? NADH plus H plus will add the hydrogen and it is going to become NAD plus. This NADH is coming from here and this NAD plus will go back here. Now, what is the name of the enzyme here? The name of the enzyme will be LDH, lactate dehydrogenase. Done? Okay. So by this, anaerobic glycolysis is the answer. Are you understanding what, friends? So this is anaerobic glycolysis completed here. So after completing this topic here, you can very clearly understand here. Yes, the only and only one reaction that you have to learn here is pyruvate is getting converted to lactate. That's all. All the remaining reactions are absolutely the same. Only one reaction that you have to learn is pyruvate is getting converted to lactate. That's all. Yes, very good, Pradeep. Now we are going to calculate the net gain of ATP here. आप मुझे ना बस इतना बता दो कि are we able to get the 2.5 ATPs from NADH? Are we getting the 2.5 ATPs from NADH? No. So we are going to get 1, 2, 3, and 4. So 4 ATPs from here. Out of that 4 ATPs, yes, 2 ATPs are actually utilized here. So what is the net gain of ATPs here? There will be only 2 ATPs. So therefore, net gain of ATP here will be 2 ATPs. In anaerobic glycolysis, the net gain of ATP will be 2 ATPs. So आज से याद रखिए, from today onwards, remember that. In RBC, which type of glycolysis will take place, sir? In RBC, the type of glycolysis taking place will be anaerobic glycolysis, and the net gain of ATP will be only 2 ATPs. Acha, why I'm telling like only 2 ATPs here? Why? Because do we have any further metabolism of lactate? Lactate का आगे कुछ metabolism होगा क्या? नहीं होगा. I told you lactate will just accumulate. There is no further metabolism of lactate. Therefore, are there any chances of getting like more ATPs here? No. We don't have any more chances of any more ATPs here. So no more ATPs, my dear friends. Therefore, net gain of ATP in anaerobic glycolysis will be only 2 ATPs from the in RBC, sir, from one molecule of glucose. Clear? Now, after completing this one here, please write down there the heading as clinical correlation, sir. And we are going to learn today about one important clinical case, pyruvate kinase deficiency. Now we are going to learn the clinical case of pyruvate kinase deficiency. Are you ready? Are you ready, my dear friends? Now, what you do is, you people try to think about this one, कि pyruvate kinase enzyme कहाँ पर आता है sir? Pyruvate kinase enzyme, I hope all of you remember, it comes in the last reaction sir, pep to pyruvate. यहाँ पर आता है pyruvate kinase. Pyruvate kinase. अब लगाओ common sense here. What is the common sense here, sir? If this pyruvate kinase enzyme will be deficient, this reaction will not occur. If this reaction does not occur here, मतलब ATP form नहीं होगा. If pyruvate kinase is deficient, this reaction will not occur, मतलब ATP form नहीं होगा. Oh my God. That means how many ATPs are forming here, sir? Only two ATPs are forming here. How many are utilized here, sir? Two ATPs will be utilized here. That means net gain of ATP will be 0. Inside the RBC, ATP form नहीं होगा. So the net gain of ATP will be actually 0. Are you understanding me? Now inside the RBC, if the net gain of ATP is 0, then what will be the consequences? अब यहाँ देखिए ध्यान से. Suppose if this is your RBC here, there is pyruvate kinase deficiency here. और अभी अभी हमने देखा है what we have seen sir, ATP will be decreased. ATP form नहीं होगा. Now on the surface of RBC there will be sodium, potassium, ATPase pumps. From the name itself we are able to understand here it is going to throw out sodium and take in potassium. And for doing so, we're going to throwing out sodium and taking in potassium. For doing so, it requires energy in the form of ATP. ATP चाहिए. लेकिन अब क्या पंगा है? What is the problem right now? The problem right now is that in our RBC, ATP नहीं है. ATP is decreased. So therefore, what is going to happen? If there is no ATP, this pump will fail to work. So ये pump काम नहीं करेगा. If this pump is not working, then what is going to happen? Sodium will accumulate inside the RBC. And not only sodium, along with that, even the water will also accumulate inside the RBC cell. You have learned in physiology that wherever sodium goes, water loves to follow. So the water and sodium will be accumulating. And then one fine day, the RBC will swell and it will actually break down. And agar RBC breakdown hoga, it will lead towards the anemia. And this type of anemia is known as hemolytic anemia. Oh my God. So you can very clearly see here in pyruvate kinase deficiency, it will lead to hemolytic anemia. Crystal clear concept. Okay. So I think you have learned this in pathology also. Let us write down the notes now. Pyruvate kinase deficiency leads to decreased ATP synthesis. That will lead to failure of sodium, potassium, ATPase pump. That will lead towards a accumulation of sodium and water. And that will lead towards a hemolytic anemia. Okay, it will lead to hemolytic anemia. Acha, if you people are done with the pathology, have you all heard about the Heinz bodies, sir? Heinz bodies or Heinz bodies, whatever you say. Heinz bodies का नाम सुना है? तो Heinz bodies का actually मतलब क्या होता है, sir? What are Heinz bodies? They are nothing but like condensed hemoglobin here, sir. अब आप मुझे ये बताइए, in this diagram or in this condition, are we going to damage the hemoglobin? कहीं पर मैंने आपको बोला है कि हम hemoglobin damage कर रहे हैं? नहीं. I told you very clearly, only there is a failure of this pump, accumulation of sodium and water. हमने hemoglobin को damage नहीं किया. So in this hemolytic anemia, is it with Heinz bodies or without the Heinz bodies? Please remember, in this one, it is without HEINZ. Heinz bodies. I'll tell you the importance of this later on. अभी के लिए याद रखिए sir. In pyruvate kinase deficiency, there'll be hemolytic anemia without Heinz bodies. Without the Heinz bodies. Okay, that's all. Done. And by this, we are done with one more important topic here. Very good. So, my dear friends, if you all remember this overview right now, in this overview, we are done with aerobic glycolysis. And after that, we are done with anaerobic glycolysis here. Along with that, we are also done with the clinical correlation also. Pyruvate kinase deficiency वाला हो गया. Now we are left out with only two things. One is link reaction, another one is a Krebs cycle, sir. और ये तो यार 5-5 मिनट में हो जाएगा. So before moving ahead, I'll give you like 2 minutes of time here. Just compare and learn aerobic anaerobic glycolysis एक बार ना comparatively देख लीजिए. फिर हम आगे बढ़ते हैं. Yeah, Dr. Arafat. Heinz bodies are formed when there is damage to hemoglobin. Hemoglobin को डैमेज जब होगा ना, जब Heinz bodies फॉर्म होते हैं, ठीक है ना? Yes, Dr. Benny. Uh, in this reaction, that is glyceraldehyde 3-phosphate to 1 3 phosphoglycerate, one phosphate group is added here in the form of inorganic phosphate here. That is not added in the form of PI. So one more additional phosphate group is coming in the form of inorganic phosphate from the cytoplasm. That is not in the form of ATP. So yes, of course, Dr. Mayank, it is the same thing. Yeah. Chalo, sir. So after learning this one here, I think aerobic glycolysis, anaerobic glycolysis, comfortably done, sir. है ना, nothing to panic here. Don't go like fast. आराम से इसको आपने रिवाइज कर लिया है. And now we are going to learn about the link reaction as well as the Krebs cycle one by one, sir. So first, let's get started with the link reaction right now. Now, link reaction में actually क्या हो रहा है, sir? I told you very clearly. It's only one single reaction. So in link reaction, there'll be conversion of pyruvate to acetyl CoA, sir. That's all. The first what you do is write down whatever you know here. From overview, we know that pyruvate will get converted to acetyl CoA. How many carbons in pyruvate, sir? 3 carbon. How many carbons in acetyl CoA, sir? 2 carbon. 3 carbon to 2 carbon here. And I told you that what is the name of the enzyme here? Pyruvate dehydrogenase. तो पहले आप क्या करो ना सर, फर्स्ट यू राइट डाउन वॉट एवर यू ऑलरेडी नो. जो आपको ऑलरेडी पता है वो लिख दो. डन. Now, once you write down here whatever you know, my dear doctors, everything is written there only. It's all about observing properly, sir. Observe the first hint here. The 3 carbons are getting converted to 2 carbons, sir. So pyruvate to acetyl CoA, there will be 3 carbon to 2 carbon. So what is going to happen here? 1 carbon will be actually lost here, sir. 1 carbon will be lost here. Fine. And 1 carbon will be removed here in the form of carbon dioxide. And I told you very clearly in biochemistry, whenever you are removing something, it is decarboxylation. If you're going to remove the carbon, that is known as what's a decarboxylation. Sir. Fine. And look at the hint number 2 here. The second hint here is pyruvate dehydrogenase. Sir. Now, what is the meaning of dehydrogenase? Removal of hydrogen. And that hydrogen will be accepted by NAD plus. Will accept the hydrogen to form what, sir? NADH plus H plus. That means what is happening here? Oxidation is taking place here, sir. Fine. So oxidation is taking place and decarboxylation is taking place here. Together it is known as oxidative decarboxylation. Oxidative decarboxylation, sir. So pyruvate is getting converted to acetyl CoA by oxidative decarboxylation. Easy, sir. इसलिए मैंने आपको कहा कि all the hint is given over there. You just have to memorize this one properly here. Now, this enzyme, pyruvate dehydrogenase enzyme, is not a simple enzyme, sir. It's actually a complex. It's not a simple enzyme. It's actually a complex. Why I'm telling you complex here? Why? Because this enzyme requires coenzymes. In total, how many? 5. इस एंजाइम को ना कोएंजाइम चाहिए सर. कितने चाहिए? टोटली 5 कोएंजाइम चाहिए सर. ठीक है ना? Now, out of the 5 coenzyme, remember number 1, there will be lipoic acid. Number 2, there will be thiamine pyrophosphate. Number 3, there will be coenzyme A. Number 4, there will be NAD plus. And number 5, there will be FAD, sir. Okay. So in total, like 5 coenzymes are required here. Lipoic acid, thiamine pyrophosphate, coenzyme A, NAD plus, and FAD, sir. And that is what is actually asked in your FMG exam, sir. You can go back and check your previous year questions. They have asked all of the following coenzymes are required for pyruvate dehydrogenase except one. So you got to remember the name of the coenzymes here, sir. Lipoic acid, thiamine pyrophosphate, coenzyme A, NAD plus, and FAD, sir. Okay, that's also. By this, we are done with the link reaction. Now, after completing the link reaction here, the next topic that we are going to learn is Krebs cycle, sir. Krebs cycle, it is also known as citric acid cycle. It is also known as the TCA cycle, sir. And TCA stands for what? Tricarboxylic acid cycle. Okay. So now we are going to learn about the Krebs cycle, and we already know the another name of this one. Krebs cycle, it is also known as citric acid cycle, also known as what's the TCA cycle. And TCA, what is the full form? Tricarboxylic acid cycle, sir. और लोकेशन तो आपको अच्छे से पता है. वेयर इज क्रेब साइकिल टेकिंग प्लेस सर? इट इज टेकिंग प्लेस इन माइटोकॉन्ड्रियल मैट्रिक्स. ये माइटोकॉन्ड्रिया में होती है. तो चलिए अब स्टार्ट करते हैं रिएक्शंस. अब ये भी यार 5 मिनट में हो जाएगा. ओके ना. असिटाइल कोए combines along with oxaloacetate to form citrate. Acetyl CoA will have 2 carbon, oxaloacetate will have 4 carbon, and citrate will actually have 6 carbons. Now this citrate will get converted to cis-aconitate. Cis-aconitate will now get converted to isocitrate. Isocitrate will undergo 2 reactions here to form alpha ketoglutarate. Citrate is going to form cis-aconitate and then isocitrate. And now that is undergoing 2 reactions to form alpha ketoglutarate. Alpha ketoglutarate will get converted to succinyl CoA. Succinyl CoA will become succinate, and then that is going to form fumarate, and then malate, and then oxaloacetate. And I told you in the overview, alpha ketoglutarate will have like 5 carbon, and succinyl CoA will actually have like 4 carbons. Okay. So first you are going to write down all the substrates of this, Krebs cycle here. And after writing the substrates, first you're going to learn them. And then let me make it easy for you people with the help of the enzymes right now. So what will be the name of the enzymes now? ठीक है ना? और enzyme के नाम पढ़ना बड़ा आसान है. Learn according to my concept here, sir. In the very first reaction, citrate is forming. इसीलिए यहाँ पर enzyme का नाम होगा citrate synthase. Because citrate is forming here, the name of the enzyme is citrate synthase. In the next 2 reactions, the name of the enzyme is the same, aconitase here. And here also the name of the enzyme will be aconitase. Aconitase and aconitase. Now in this, what is happening? In the very first reaction, aconitase is removing the water molecule. In the second reaction, the same aconitase is adding the water molecule, sir. Ek bari, it is going to remove the water molecule, and once it is going to add the water molecule. So write that and forget about that one. They will never ask in the exam, sir. Exam में नहीं पूछा जाएगा. Now, once you are done with this one, now what you do is start from isocitrate, sir. From isocitrate, every alternate step oxidation will take place. From isocitrate, what is going to happen? Every alternate step oxidation will take place. So oxidation here, leave this reaction, again oxidation here. Leave this reaction, again oxidation here. Leave this, again oxidation here. And the moment I'm telling you oxidation, I think my students are expert in the oxidation reaction, sir. Tell me what is the meaning of oxidation, sir? Removal of hydrogen. And when there is removal of hydrogen, what is the name of the enzyme? Dehydrogenase. So here it will be isocitrate dehydrogenase, alpha ketoglutarate dehydrogenase, succinate dehydrogenase, and then here it will be the malate dehydrogenase. Perfect. every alternate step oxidation will be taking place. And if it is dehydrogenase here, whatever hydrogen will be removed here, that will be accepted by NAD plus to form NADH plus H plus. Hydrogen will be accepted by NAD plus to form NADH plus H plus. And again, here also, in the third reaction, you have to be like very careful, sir. In succinate dehydrogenase, what is going to happen? FAD will accept the hydrogen to form FADH2. And finally, again, the same thing here. NAD plus will accept the hydrogen to form NADH plus H plus. Wow. So there are totally like how many oxidation reactions here, sir? 4. Out of the 4 oxidation reaction, at 3 places you're getting NADH. At 1 place you're getting what, sir? FADH. Now, once you are done with this one, now we are left out with only 2 places, sir. Fumarate to malate, the name of the enzyme here is fumarase. And here it will be succinate thiokinase. Succinate thiokinase, that is the name of the enzyme. And here, out of all the reactions, I made it easy for you people, sir. The only thing is you have to memorize this one here. But there also there is one hint there, succinate thiokinase. Kinase means what? Kinase means transfer of phosphate group. Phosphate group will be transferred to ADP. It will pick up the phosphate group to form ATP. Is ATP forming here? Yes. And it is forming by which method, sir? SL. Substrate level phosphorylation. By this, your Krebs cycle is done, sir. Are you understanding, my dear friends? Krebs cycle भी यहाँ पर हो गया, sir. And now calculate the net gain of ATP in Krebs cycle here. NADH 2.5 ATPs, NADH 2.5 ATPs, and this NADH 2.5. So 2.5, 2.5, 2.5, totally 7.5. And then from FADH 1.5, 9. And then from substrate level phosphorylation 1 here, totally 10. Wow. So please write down there. Therefore, in Krebs cycle, net gain of ATP is 10 ATPs, from each molecule of acetyl-CoA. From each molecule of acetyl-CoA. So whenever you're going to begin from acetyl-CoA, जब भी आप यहाँ से start करते हो ना, there how many ATPs are formed, sir? Totally 10 ATPs. Then the next thing is rate limiting enzyme. आप regulate कहाँ पर करोगे? Control कहाँ पर करोगे? Isocitrate dehydrogenase will be the rate limiting enzyme, sir. Isocitrate dehydrogenase will be the rate limiting enzyme. Okay. And one more MCQ that they're asking, sir, in the exam is, yes, vitamins required in Krebs cycle. Vitamin B1, B2, B3, and B5. Vitamin B1, B2, B3, and B5. These are the vitamins required in the Krebs cycle, sir. Okay, that's all. So by this, we are done with everything here. अगर आप ध्यान से देखोगे, तो we are done with the rate limiting enzyme. We are done with net gain of ATPs. Then the vitamins required, all the reactions, location, and the name, everything done. Are you clear? That's all. By this, the entire Krebs cycle topic is done, sir. And not only the Krebs cycle topic here. Yes, we are done with the entire overview here, sir. ये overview याद है आपको जो हमने break से पहले मैंने आपको बताया था? Yes. Aerobic glycolysis हो गया, anaerobic glycolysis हो गया, and then we are done with the link reaction as well as the Krebs cycle, sir. This big overview is done, sir. Okay. तो जैसे आपको मैंने कहा था, it will take almost like 1.5 hour to 2 hours of time here. तो ये यहाँ पर why this is done, sir. One big concept is completed in carbohydrate. अगर ये हो गया मतलब carbohydrate metabolism में big concept is done, sir. Understanding here? Hello everyone, are you understanding here, sir? बढ़िया sir. So that is the reason why I told you that, after the break, we'll do this entire concept at once because I wanted to finish all these topics in one go, sir, so that you'll have a proper concept here. So aerobic glycolysis हो गया, anaerobic glycolysis हो गया, link reaction is also done, Krebs cycle done, as well as we are done with one clinical case also. Pyruvate kinase deficiency will lead to hemolytic anemia. Many things are done here, sir. चलिए बढ़िया सर, ठीक है ना. So after this, the next concept that we have to begin is gluconeogenesis and glycogen metabolism. That is like another big story, sir. It will take another like 1.5 hour or 2 hours of time. So better we'll take a short break here. After the short break, we'll continue, sir. Okay, we'll do it like topic by topic, sir, concept by concept. So this one concept is done. Another concept we'll do it after the break, sir. Is it fine? Okay, जी. Thank you, Tabriz.